So, friends, first of all, I extend my warm welcome to our esteemed expert, Professor Praveen Ingole sir, to this refresher course and particular to this session. I also extend my warm welcome to all the learned participants, those who have gathered in this refresher course for this particular session. So first, we'll take the brief introduction for our guest. I think it's Dr. Inwati, Dr. Gajendra Kumar Inwati sir. You are requested to please introduce our guest in brief. We will start with the session. Yes, please, sir. You can start.
Okay. Yeah. Good morning, one and all. I'm Dr. Gajendra Kumar Inwati. Sir, I'm joining with this Ravi Bansal's desk to avoid the network problem. I already joined from my system.
You can please continue, sir.
Yeah. Good morning. Good morning, Dr. Praveen G. Ingole sir and organizer committee. I'm Dr. Gajendra Kumar Inwati from School of Chemical Science from DAB. So I'm here to introduce Dr. Praveen G. Ingole sir. Sir is principal scientist and associate professor in the engineering Jorat, Assam. In his professional career, it included dedicated researcher with over 14 years of research experience and teaching experience also in the field of membrane science and technology, recognized globally as one of the top 2 scientists worldwide for the consecutive years of 2022 to 25, which is really remarkable in the field of research and science. And he has done his PhD in the year of 2012 in the CSIR laboratory CSMRI. And he's also MSc in organic chemistry from Nanded. And in his research experience, he is right now serving as a principal scientist in East Jorat, and he has been already served as a senior scientist from 2021 to 2025. Also, the scientist from 2017 to 2021. SIR installed, and he researchers in like Korea Institute of Energy Researcher, South Korea, 2013 to 2017. In his research specialization, he has included like membrane science technology, basically development of thin film nanocomposites membrane and separation processes. His innovations also developed the vapor phase interfacial polymerization technology, which is like green process for TFN membrane preparations. He has been elected as a fellow of the Maharashtra Academy of Sciences in the year of 2022. He has been also as editorial associate of Frontier and Frontiers in Materials. He has been also awarded for the like Springer Best Paper Award in 2022. He has been also received Excellence Researcher Award from Kair, South Korea in the year of 2014 to 2016. In his research, he has been published more than 111 international and national research paper, including one book and 17 book chapters. And he has also published more than 7 national and international patents. In his project, 26 completed and ongoing project, and he has been served as an PI, co-PI as mentor. In his mentorship or guided 3 PhD students to complete 5 currently going on. So that all was like about sir and sir.
Yeah. Thank you very much for your giving nice introduction. So may I start now the presentation?
Yes, sir, you can please start, sir. We are waiting for you.
Are you able to see the PPT?
Yes, sir. Yes.
Yes, sir.
Yes, sir.
Good morning, sir.
Good morning. Good morning, ma'am.
Yes, sir. Please make it like full screen, sir. Yeah, it's fine now.
One minute. It's some issue. Okay, so first slide is looking right now?
Yes, sir, it's fine now.
Okay. Yeah, a very good morning to all, one and all present here in the today's session. So today I am going to present the work, whatever we have done in our laboratory under the heading Chemistry of Advanced Membranes and Functional Materials for Sustainable Gas and Liquid Separation. So whatever we have done, so I will going to explain briefly regarding the membranes. So what the chemistry is playing role while fabrication of this membrane. Particularly our work is on the materials as well as chemistry, and membrane is part from the physical chemistry, or you can say the polymer chemistry, as we are using the polymeric membranes for that. So particularly after the synthesis of the material, the fabrication of membrane, and then their application for gas as well as the liquid separation. So there is problem actually. I don't know why directly going slide number.
So what can you do? You can share your entire screen. Whenever you are sharing particular window, that problem will be happen, sir.
Okay,
You
so
can stop sharing once and share your entire screen, sir. You can please reshare, sir, your entire screen.
I have shared the screen actually.
Just go with slideshow mode.
Yeah. When I make the slideshow, that it going to directly slide number 14. I don't know what is.
Now it is moving in the slideshow, sir.
Yeah, but directly it goes to slide. Yeah, it's stopping on the slide 15 only. When I change the slide. Just 1 minute. Yeah. Now it's solved. Okay, so I'm sorry. It's okay now, right? Hello?
Yes, sir.
Yes, sir. It's
Ah,
fine.
Okay,
Yes,
okay.
sir.
Yeah,
Yes, sir.
yeah.
Yes, sir. It's
There
okay.
was some issue in the slide. Anyway, now I sorted out. So, as I am belongs from the CSR Northeast Institute of Science and Technology, this is the CSR lab located at the Assam, Jorhat, and we are near the Kaziranga National Park, well located with and connected with the airport as well as the railway and road. And our institute is nearby the Brahmaputra River, that is, and Majuli Island, that is the biggest river island, as you know. So nearby that area, our institute is located, and we have the all facility to do the research in our institute. So all sophisticated instrumental facility we have to do the R&D work here. So now I'm going to present the work. So to understand everyone, so what is the membrane? As you all know, we are using the membrane in our daily life in different purposes. For example, the water purification, the well-known example for the water purification, we are using the water purifier in our household. So there also we are using the membrane module. Through that membranes, the water is going to purify. So how these membranes, so not only the water purification, there are the several applications nowadays, even the even medical gas separation, industrial gas separation, the biogas concentrated and dialysis and other application also membranes are using. So how that membranes work? So this is membrane is the selective barrier. It means through the membrane something can be passed and something can be rejected. So what that something can be passed, So that is the required compound that is passed through the membrane. And this membrane is work on the pressure driven processes. It means for the operation, we need the pressure. That's why in our household, whatever the water purifier you are using, so there is the one motor. So that motor is applying the pressure, and through the pores of this membrane, the water is only the water molecule is going to pass through the membrane, and the salt molecule or unwanted things, those are rejected through the membranes. Okay. So basically, this is the phenomenon or the methodology works in the membrane separation. So based on the size of the membrane, it means the pore size, there are the classes of the membrane. Bigger the pore size, that is the microfiltration membranes require the small pressure, and pores are the bigger. So the bigger pore require the small pressure, and the membrane is the microfiltration. Among the so microfiltration, then the ultrafiltration, then nanofiltration, and the reverse osmosis. So there are the four major classes of the membrane. The reverse osmosis case is the pore size is very small, that is the 0.001 micron, and mostly in the our houses, that is the reverse osmosis membrane people are using for the water purification. But as you know, in our body, we require the essential metal salts also, or essential ions also. So for that, what we are doing as a researcher, we are developing the membrane, that is the nanofiltration membrane. This membrane is the membrane where the required monovalent ions can pass through the membrane, so that is required for our body. So accordingly, we are working in our laboratory on the nanofiltration membrane. And also our application was the gas separation also. So here we are using CO2 capture. It means the CO2 separation also, then the natural gas purification, hydrogen purification, volatile organic component removal, as well as the oxygen enrichment. So this part we are also working on our body. Then the water remediation to remove the heavy metal ions, dye and microbial removal, oil water separation, membrane bioreactor, and nutrient recovery. Also, we are working on the desalination, seawater desalination, brackish water treatment, high salt rejection, wastewater desalination, and industrial water supply. Another part, also biomedical application. Here we are only on the bioseparation. Remaining, we will look in the future. The biogas separation also, the concentration to make the methane concentrate. So CO2 methane separation, biogas separation also we are working. And recently we have started working on the fuel gas application and microalgal working with the micro-industrial industries. So as I told, there are the various classes of the membrane. Like the first generation classes has the microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. So particularly we are working on the two classes, the nanofiltration for the water application and the purification in the biological separation, the bigger size molecule removal. Then the second generation membrane processes, there are the gas separation, evaporation, and membrane distillation, where we are working on the gas separation membrane. So these three classes of membrane we are working in our laboratory. So how it's work, so that will come in the coming slides. So now coming towards the breakthrough of the membrane sciences, how the membrane journey is start. So in 1963, the first article came by using the asymmetric cellulose acetate membrane. So that time the researcher used the cellulose acetate as a fabrication of the membrane. So the professors Loeb and Soryarajan was the first inventor of the membrane science, who have not get Nobel Prize but nominated 2 times for the Nobel Prize award. So they have developed the membrane, and in 1965, so they have commercialized it as a thin film composite membrane, where that membrane is prepared by the interfacial polymerization. So what is the interfacial polymerization? So I will explain in the coming slide also very nicely, so you will understand it clearly. Now that era started for the application of membrane in the industrial scale as well as the water purification application. When the nano era came from the 2002 or 2005, you can consider like that. So in that nano era, people have started to use the nanoparticle incorporated in the membrane and to develop the thin film nanocomposite membrane. So here, the first article has been published by using the carbon nanotube incorporated membranes. then the several nanomaterials has been developed by the researcher, enhance the surface area of the nanoparticles, which can give the high surface area for the different application, as catalysis and other cases, and even in the membrane science also, the researcher we are using to develop the thin film nanocomposite membrane. So by using this, the performance of the membrane has been enhanced. It means, suppose for example, we are taking the in general example. So for the water purification also, so we have to calculate it in particular time, how much purified water we are getting after the removing of the contaminant for that. So in the small area, the large quantity of water we required in particular period of time. So for that, we are incorporated the nanofillers for that to get the high surface area and get the more channel to pass the water through it. Okay, so accordingly, the nanofillers has been incorporated and to develop the thin film nanocomposite membrane. So there are the several processes for that to develop this thin film nanocomposite membrane. So interfacial polymerization is one of the method for that, and another one is the hyperphase interfacial polymerization method. So what is happen in interfacial polymerization case? So the amine monomer and acyl chloride monomer is interact each other on the interface and get the polyimide structure. That is the thin layer crossing structure. So which is the thin selective layer for the separation application. And the concept is the vapor phase. Here we are not using any organic solvent. Just on the vapor phase reaction is going on. So these are the initiative we have taken in 2022. We have published the first article in the history of membrane science, that is the membrane developed by the hyperphase interfacial polymerization. So this work is done by our group. So I will explain in the coming slides also. So as we are working in the national laboratory, so we have the mandate given by our headquarters, CSIR Delhi. So as CSIR North Institute of Science and Technology Assam, we got the two mandate, that is the environmental care and the herbal formulation, as we have to work under this mandate area. So our group, we are developing the polymeric membranes and membrane-based process for separation of the flue gases to control the air pollution, wastewater treatment, removal of heavy metal ions and hazardous micropollutant from the water, to take the environmental care. And the herbal formulation, we are also working on the enantiomeric separation. Here, basically we are working on the amino acid separation and the biomolecular extraction and purification. So the Northeast is highly, we have the natural sources, that is the biomedicinal plant. So from that we are extracting the biomolecules, and that is separating and purifying by using the membrane. So that is also I will explain in the technology, how we have developed the technology on that. So in coming slides. So this was the mandate, and these are the mandate. Accordingly, we are implementing for the water treatment, water purification, industrial mixed gas separation, flue gas separation, chiral molecule separation, biomolecules. So what we are doing, particularly, we are fabricating the polymer membrane, that is the polysulfone, polyether sulfone, polyimide, polyetherimide, etc., in the form of the flat sheet or the hollow fiber membrane. Then, after fabrication of this membrane is not selectively separated anything. So we have to make the selective layer on that membrane surface. So for the particular application, suppose the membrane required for the water purification, so their coating layer is the different. For the gas separation, coating layer is the different, because we have to make the selective material for that. Then the other application also, accordingly, we use the material, synthesize that material, then use for the development of membrane. So on that, we have still patented the 7 patent on that, and also transfer the 4 technologies. So how it works? So here you see the hollow fiber membranes, how we have developed this hollow fiber membranes. This is the tube-like structure of the membrane. We have the fabrication machine for that. We make the dope solution of the polymer, and then we have fabricated this membrane. This is the porous membrane. Then we make the bundle of this and make the module. You can see here the module here. Small to bigger size of module we have developed. Even the curtain type of module also we have developed, and we have implemented in the large scale. So how it will work in the large scale, that will also I will explain. But before that, as the chemistry point of view and the material point of view, after the fabrication, we have to find out, characterize the membrane. Either this membrane has been formed or not. So here, by using the same analysis, we found that the membrane structure is symmetric or asymmetric. Okay, so pore structure we get, that is the asymmetric structure, the different pore size of the membrane having there, and even the nanochannel. But directly we cannot use here as it is after the fabrication of this hollow fiber. So what we do, we make the thin film nanocomposite layer by using the interfacial polymerization on the inner side or the outer side of this membrane. So it can be the selective layer, and this coating layer is act as a selective layer for the separation application. Okay, so how it will be applied? So it is coming in the coming slide. So first application, I am going to discuss about the membrane for the liquid separation. So as we are working on the nowadays, as we know, we are all have to work on the Sustainable Development Goal, which is given by the UN, and accordingly, every researcher is working on that. So we are also working on the considering this the Sustainable Development Goal, and number 17 goal is the sustainable. Sixth goal is the clean water and sanitization out of this 17 sustainable development goal. So here we are working for that to provide the clean water for the people. And how we are making that? So as I told, we are developing the thin film composite or nanocomposite membrane by using the interfacial polymerization. Okay, so you consider here and keep in mind that after the development of the polymeric membrane, either the flat sheet or the hollow fiber membranes is having a highly porous structure. So it cannot directly give the results. It means whatever you are passing through that, you are getting in the second side, in the purified side. So we cannot implement that. So we have to make it selective. So for that, we are going to coat the thin film composite or the nanocomposite layer. Composite means without the nanofiller, and nanocomposite means after incorporated the nanofiller in the monomer solution and get the processing structure containing the nanofillers. That is the nanocomposite layer. So here simply giving the organic reaction is like that. The metaphenyldiamine having the two amine monomers are there in the meta position, and the trimethyl chloride having the 3-COCOL group. So this is without any catalyst, without any condition at the room temperature. It reacts this highly reactive amine monomer and acyl chloride monomer together and get the crossing structure, that is the CONH, the amide linkage here. And everywhere this linkage has been formed, and you can get such a kind of cross-link structure. You can find here the thin cross-link polyamide layer. Okay, and this is the selective layer. If we incorporate the nanofillers in the aqueous phase monomer, then the nanofillers will stuck on the surface of the membrane, or they can also take part. As I am working from last 20 years in this particular area, so we are functioning this nanofiller, so that also can be take part in the interfacial polymerization, so that cannot be leach out through the membrane, as the membrane is work on the pressure driven processes, as we have to apply the pressure for the application. So it cannot be leach out. So how can we'll function that? It will come on the next slide also. So basically you consider here. So this is the thin film composite membrane we have developed. Okay. So on the interface, in the aqueous phase and organic phase, reaction takes place on the interface, and we get such a kind of structure. Okay. So for that, this is the thin layer, but the support layer is we are developing by using the non-solvent induced phase separation. Here, very simple method. The polymer solution, the polymers, bead of the polymers we took in the solvent, that is the NMP, N-methyl pyrrolidone, at the certain temperature, that is 60 degrees Celsius. Within 6 to 7 hours, the homogeneous solution has been formed. And to make the pores on that, we use the PEG having the 400 molecular weight as a pore forming agent. And we have casted the membrane and make the phase inversion in the coagulation bath. Here, in the coagulation bath, we use the water and the surfactant. In the water, the polymer has been phased out. And why the surfactant we are using? Because we want to fast transportation of this non-solvent in the water, so it can become fastly and pores can be formed. So after that, you see, after the fabrication membrane, such a kind of pore structure has been formed in the same images. Okay. And immediately through this pore, whatever you are giving, like the gas molecule or the water, the water molecule, so easily pass through the membranes. Okay. So such a kind of asymmetric structure or the pores has been formed or the nanochannel has been formed on the surface of the membrane. So as I told previously, so after the fabrication of this structure, we make it selective by using the interfacial polymerization, using the amine and acyl chloride monomer, as well as using the nanofillers in the amine monomer, so to get the thin film nanocomposite layer. Okay, so my point was to develop the selective layer, okay, for the application purposes. But this was the amine monomer was in the water phase and TMC was in the organic phase. Here, the organic solvent, we use the TMC. But what we have done in the next stage, we remove the NHN as it is the toxic solvent if we are using membrane for the water purification. So this TMC, we took the TMC vapor. So once the amine monomer absorbed by the membrane and these vapors of the TMC interact each other on the interface. So what happened? We get the cross-linked structure of the membrane on the surface of the polymer support layer by using the vapor phase interfacial polymerization method. So in this process is the green process where we remove the solvent and make the thin film nanocomposite layer. So how the nanocomposite layer has been formed? So you can find here we have taken the nanofillers 2D nanoseeds, that is the synthetic talc, and having such a kind of structure, and then the amine monomer, that is the trimethyl chloride, and another one is the DETA, diethylene triamine, as a amine monomer. So accordingly, the cross-link has been formed here on the interface and membrane has been fabricated. So different composition of nanofillers we have took to find out which concentration is suitable, and we are getting the highly selective membrane layer. Accordingly, we can go for the large scale production of this membrane for the application purpose. So these are the parameters we have used. First of all, we have took the membrane, then after that coated the PDA, polydopamine, make it more hydrophilic, and then to make the thin film nanocomposite layer on that membrane. So you can find here the polymer substrate, then the PDA layer and TFC coating layer here. And the nanofillers we have used, the 2D nanoseeds, that is the synthetic talc we have used for that, and 2D layer structure, that is also interacted while the interfacial polymerization layer, and get the thin selective layer. In the same images, you can find this surface of this membrane as well as the cross section, how much the thickness of this membrane has been formed. Also, the FTIR has been used for the functional group identification, as well as this membrane used for the heavy metal ion removal. So we have to check the membrane surface charge. What is the charge on the membrane? Either is the negative charge or the positive charge. So for that, we use the zeta potential. Accordingly, we can take for the application purposes. So which ions we can pass through the membranes and how much will be the result for that. So here we have took the sodium sulfate as well as the magnesium sulfate as the salt along with the copper sulfate and copper chloride. And we found that we got 98.96% rejection of the sodium sulfate and this 95.35% rejection of the magnesium sulfate. So accordingly, we can use to remove the salt from the water and get the purified water. So accordingly, as the performance of membrane we have tested along with the flux, how much flux this membrane has been getting, and how the membrane now, as I'm telling you that. So the point or the question should be here like that: if we are using the membrane for any removal of the contaminant from the water, so is the pores are going to block or not? So for that we measure the antifouling characteristics of this membrane. So what we do for that in the last this image you can see, or the graph you can see here, we apply the purified water first. Then we foul the membrane by ourselves to provide the BSA molecule, that is the high molecular weight component, bovine serum albumin, and the pores we block. Again, we apply the back pressure and we found out how much membrane has been recovered. Okay, so either we can implement this membrane in the large scale as well as the long duration point of view. The several months should be performance ratio. In this corner, left corner, this image or the this graph is showing that membrane's recovery ratio is above the 94%. So this membrane is not going to foul, and we can use this membrane in the large scale. Also, the membrane showing the antibacterial characterization study also in the liquid. It means the liquid case there is no any bacterial growth on the surface of membrane, and we can use this membrane in the continuous mode of operation in the several months also. Okay, so accordingly, in the second case, we use the graphene oxide. That is also, as I told, we have functionalized it using the amine functional group. So it cannot be leached out on the surface of the membrane, and the membrane has been formed by using the hyperphase interfacial polymerization. Okay, here also to reduce the cost of the material, we use the spray coating method, not the dip coating method, because the dip coating method we require the more solvent, but the spray coating method, that's only the few ml of solvent we can use for the square meter of the fabric, coating of the membrane. Accordingly, spray coating method also we have applied here, and membrane has been developed and characterized well by using the same XRD, then the FTIR, zeta potential, etc. Contact angle also, as membrane is hydrophilic and or hydrophobic nature, and the membrane performance also has been tested with the different heavy metals ion, and we found that up to the 90% rejection has been found by using such a membrane. Also, membrane showing the anti-fouling nature and antibacterial nature, and you can find, you can see here the BSC solution having the 500 ppm concentration. After that, we can see the clear solution up to this after the 6 hours. So it means the above 98% rejection of this BSA molecule has been found. Also, another material TiO2 as we have taken, and this material we have tested for the pharmaceutical industry water, where having the antibiotic are present in the this municipal waste, pharmaceutical waste water. So there also we have tested the TiO2, amended TiO2 material along with the diethyl triamine as a diethylene triamine monomer and trimethyl chloride acyl chloride monomer. Crossing has been formed and membrane has been developed. This membrane also has been characterized well by using the different physicochemical characterization technique, and then we have implemented for to remove the antibiotic from the water. Here we have taken the different antibiotic, carbamazepine, then the thermapine, and SMZ. These are these three antibiotic we have tested, and we have found up to the 98 to 99% of rejection of this antibiotic from the water to get the purified water for that. Along with the flux also is very good here. You can find here up to the 90 LMH, means liter per meter square per hour, the purified water we are getting. So after this tested, then we have tested the Brahmaputra river water. So the real water we have taken and we have tested. So we found that the Brahmaputra river water also we are getting the purified water. So what is As the national laboratory, our target is to provide the purified water to the people. So here, the main source of water is the Brahmaputra river. So accordingly, this water also we have tested. So here I am showing the result, the analysis is of that. So what are the main component present that is the very hazardous to the body? That is the arsenic. Arsenic is highly present in the Brahmaputra river water, also the groundwater of this Assam, as well as the northeast part of the India. Then the lead also and the iron. Iron is the major source which is present in here water. Even you can see the groundwater showing the red color kind of water. So we have to treat it for that. So in this table, you find that what are the components we have found in the metal ions as well as their concentration in the river water. And after the separation, so how this concentration has been reduced. So it means when you calculated it, the lead 99%, then the iron completely removed, and the arsenic 84% has been removed from the water. Also, among the other material, other metal ion also we have rejected very nicely by using this thin film nanocomposite membrane. Then further that, what we have done, we have taken this surface water, the pond water that is in the our campus, so that also we have purified. So here the different temperature as the northeast, the in the morning is the cold, afternoon little warm, then the afternoon again afternoon more warm, then again evening this is the temperature changes. So when we are implementing the membrane technology, we have to we have to find out that either the low temperature as well as the high temperature, how much will be the performance of this membrane. So that also the temperature base we have tested as well as the weekly results we have calculated in the continuous mode of operation. So up to 8 weeks, we have tested the similar membrane, and result you can find here. The membrane is not going to foul. Is only you can find here the TF means other membrane have foul more, but the TFN1 membrane is fouled only 3.29. It means only 3% has been fouled. So membrane has the anti-fouling nature and giving the continuous and constant flux, the purified flux of the water. Accordingly, the rejection of the total carbon as well as the COD as well as the BOD analysis we have done, and we found that the membrane showing the very good rejection up to the 75% of rejection, and the TFN2 membrane little bit less rejection has been found, but the TFN1 membrane 71% of the COD, total carbon 74%, then the total inorganic carbon 71%, and total nitrogen 48% has been rejected. It means this water can be applied for the drinking purposes also. So accordingly, the water analysis also we have done, and here the another component what was present in the water that also has been rejected very well, and now the purified water we are providing to our campus also. So this was the water purification application, those we have taken. Then the gas separation, what we are doing for under the gas separation and what it is working. So nowadays, as you know, this is the CO2 is the major component to enhance the temperature of the global. Everywhere nowadays people are facing the global warming effect. Now India also was facing, also we are now currently facing, and now Europe, what is the condition of Europe, you all know how they are facing this heat waves problems. So CO2 is the major issue for that, enhancing the temperature, and for that enhancing the pollution, and for due to that enhancing the temperature. So what we can do as a membrane researcher, so we are working in this particular area as the Indian government also have decided up to the 2050, so make the net zero this CO2, and there are several projects are going on that. So what we are doing in this connection is by using our membrane technology. Okay, so here what we are doing for that, we are fabricating the mixed matrix membrane for the CO2 separation and the thin film nanocomposite membrane. So first of all, I will explain this mixed matrix membrane. So what is the mixed matrix membrane? So, I am audible now, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes,
So in the mixed matrix membrane, we use the polymer as a dope solution. And in the dope solution, we are incorporated the nanofillers for that. Okay, not using any amine monomer, aqueous monomer. Okay, but as you think here, if we are directly incorporating the nanofillers in the membrane, so we require the more nanofillers for that. Okay, so cost of the materials having enhanced. Memories is giving the good result, no doubt, but if cost is very high and result is not that much good, it means we cannot implement it in the commercial point of view. So always as a researcher, we think that like that, the membrane cost or the materials cost should be lower. So for that, we use the to make the thin film nanocomposite membrane as only the support layer, we use the thin layer, which will be the selective. Okay, but the first work we use the mixed matrix membrane. Here we incorporated the graphene oxide, then the composite of graphene oxide with the MOF UiO 66, then the graphene oxide with closite and MOF, as well as the closite MOF directly and one without this closite MOF. So total 7 concentration we have taken, having the 58% of this loading, and membrane has been developed. So after the development of this membrane, we found that the material has been present on the in the membrane. Okay, not on the membrane, in the membrane, and this material by using the XPS analysis also we have found that this is means bounded with the polymer dope solution, showing their binding energy. Then the FTIR analysis also showing that this materials is nicely present in the membrane. The membrane also showing the amorphous structure, not crystalline structure. Then the performance of this membrane with the biogas.
Hello, Professor Engole sir, you are not audible.
I think
Sir.
the biogas also.
Hello, Engole sir.
To make
Sir, your voice is low.
Yeah, sir's voice is breaking. Hello, Professor Engole sir.
hello.
Yes, sir, you are audible. What happened? I think there is some technical glitches or the network issue. You can put your audio off, video off,
Okay,
so
okay.
we can hear you very clearly, sir.
Okay. Now it's okay.
Sir, you are not audible.
Now audible, sir, and visible your slides.
May I audible or not?
Yes, yes. Audible, sir.
Yes, audible, clearly.
Okay. So this slide, you heard or not? Hello.
No, sir.
So, okay, I will
Yes, sir,
start
from this side.
Okay. So, as I was telling like that, so we make the mixed matrix membrane for the CO2 separation by using the different loading of different concentration material, and after that we have characterized this material to identify either this make the mixed matrix or not, and material are present on the surface in the membrane or not. Accordingly, FTIR, then the XRD, as well as the same analysis has been done, and we have implemented this for the biogas to separate the biogas and make the concentrate methane, which can be implemented for the burning process as a fuel for the our guest house. Here we are using this plant for the guest house application. Guest house, there they are cooking on that. So this is implemented, and we found that for this CO2 methane in the it means the biogas separation, the selectivity of the CO2 methane is 46.71. This is the huge selectivity. So we get the concentrated methane which can be applicable for the fuel process. Also CO2N2, which is present in the industrial gases, also we have tested and we found that here the CO2N2 selectivity is huge, that is the 77.57. But the permeance, because only selectivity we don't require, we require the permeance of these gases also, but it was quite less or the very low. So what we have done in the next case, we have used the hollow fiber membrane for that. And in the hollow fiber membrane, we took the mesoporous synthetic hectorite as a clay material, and this is we functionalize with APT, that is the silica based material, that is the 3-amino propyl trimethoxysilane. Uh, 3-amino propyl trimethoxysilane, and this is grafted on the surface of the mesoporous synthetic hectorite. 5 different composition we have make the 5 membranes, and we have tested this membrane for the application purpose. Again, this slides removed. Hello? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir, working, sir, working.
Okay. But these graphs are not showing, na?
Yes, graphs are unable to see.
Not available, right?
Yes.
Yes, sir, graphs are not available.
Graphs are not
Not
visible,
visible.
sir.
Yeah, not visible. I don't know
This
what
is
is
visible,
happening. Anyway, so I will explain the where is the available. Okay. So after that, we have this 5 membranes has been fabricated, and the as I told on the hollow fiber case, on the inner surface we have make the selective layer for that. You can find here the inner surface selective coating layer. And the AFM analysis, the surface roughness also we have to calculate it. Either this membrane is having the good surface roughness for the application purpose or not by using the atomic force microscopy. So we have calculated that one. And here you can see the result what we obtain by using such a membrane for the biogas separation, as well as the to remove the water vapor from the flue gases. So here considering the point, the flue gases or the biogas. So biogas, it means only the CO2, methane is the major, and the H2S is also the side product for that. Water vapor also is the major role playing role there. So we have to remove the water vapor from that. In the flue gases also the water vapor is the major issue, along with the CO2, N2, H2S, and other small concentration of other SOx and NOx gases are present there. Okay, so accordingly, we have implemented this material for the biogas separation as is the flue gas separation, and we got the very good result by using such a material. As a permeance of this is 240 2485 GPU as maximum, along with the 725 U as a selectivity. Then to remove the SO2 from the flue gases, so we have implemented this hollow fiber membrane, and the SO2 removal efficiency also of this membrane is very good. That is the 702 GPU gas per unit, along with the 91% of the removal efficiency. So you can see this result. This was the very good results. We have implemented this in the large scale also. So I will explain that one, how this developed laboratory scale, how we can go for the large scale separation. So another material I want to explain here, as nowadays people are working in the MXN material. So MXN is the very good material nowadays, having the 2D material, having very huge surface area, and in the every application people are applying this material, even the electronic case also, as well as the material different application. So we have also worked on this MXN based material for the gas separation application. This was the first article by using the MXN material in the gas separation we have done, and we achieved the very good result here. So how we have fabricated? So we took the polyether sulfone as well as the polysulfone as a polymer material, fabricate the membrane by using the phase inversion. Then after that, make the selective layer on this fabricated membrane by using the triacid chloride vapor with the vapors and the amine monomer with this MXZ. So here you can find the structure of this material. 3 different composition has been used without and with 3 different composition. Then the material has been tested, as well as membrane also has been fabricated and tested for this CO2 N2 separation. And here you see the result where I was explaining the last slide. It was the 89 GPU as the permeance of CO2, but here we achieve the 418 GPU as the permeance of the CO2. So this, after getting such a remarkable result with the selectivity of 42, so now we can go for the large scale separation of the CO2 by using this thin film nanocomposite membrane. So how we compare our result with the other people, what they have done. So in the membrane science, for the gas separation, there is the Robinson upper bound limit. So this is the Robinson upper bound limit. This line you can see. If anyone researcher result came above this line, it means the permeance as well as the selectivity. So directly you can go for the industrial scale production of this membrane and use the membrane for the industrial scale. Directly we can transfer the technology for that and implement for the industry level. Okay, so now we have reached up to the this upper bound layer. Above the upper bound this layer, you can see these are our result. The star were showing. So these star shown results are our lab results. Okay. So recently we have published this work in the small village journal, and this is the very good journal also. And patent also has been already, we have filed this work. So now we are going to transfer the technology on this work. And so this was the basic work, whatever we have done in our laboratory. Also, this work, as I told, we have filed or granted 7 patents, and the 4 technologies also already we have transferred to the industry. So that also I am going to present how we have transferred and how it's working on the large scale. So briefly, we will go for that. So as before going to that, I want to discuss with the market of the membrane science. So the currently as per the compound annual growth rate, 7.2% growth rate is enhancing in the membrane science for the different application of this membrane in the food and beverage industry to make the concentration of this beer and food, beverage and foods. Then this the water treatment application, then the healthcare sector also, and other like gas separation and desalination, dialysis and other fields. It means it is expected that up to the 9.9 billion USD of this market of this material up to the 2028. And per year, it's growing the market 7.22% in this area of the ultrafiltration, nanofiltration, microfiltration, then the chromatography as well as the reverse osmosis. These are the this is the market surveys I have taken from the Fairfield Market Research. So then what we have done for the transfer of this technology. So as I told, we have fabricated this flat sheet membrane as well as the hollow fiber membrane, make the small scale module as well as the big scale module. Here you can see, and having the high surface area, that is the 4,393 cubic centimeter, make this module, that is the spiral wool module, and directly we have tested for the separation application. So what application we have tested, that I will show. So these are the facilities we have for the fabricated of this membrane, that is the flat sheet membrane as well as the hollow fiber membrane. So, and for the testing of this, we have the gas separation setup and a liquid separation setup. And after the separation, for analysis, we have the ion chromatography, HPLC, and for the gas case, the GC, gas chromatography. Okay, and the physical chemical characterization, we have the centralized facility for that. So here we can do the same TEM, XPS, NMR, whatever we required, physical chemical characterization we required, so that we are doing the centralized facility. But these facilities we have developed in our laboratory. So fabrication as well as the other analysis of this our experimental results. So these slides I have already explained as the Brahmaputra river water, but this part I have not explained. So this is the another membrane module setup. Those we have developed, and we have make it the bigger scale in the industry also. So we had the project Numerical Refinery Limited, where as the industry, the major pollutant is the phenol that is coming in the feedstock. So here we feedstock. So we have removed this phenol, that was the 400 ppm concentration of this phenol, that is the hazardous material coming in the water, industrial wastewater. So that we have removed by using the membrane technology also. And this is the one plant, 5,000 liter per hour capacity we have installed in the Numaligarh Refinery Limited, Numaligarh in Assam. Also, we have the solvent extraction facility here, the biomolecule extraction as well as the purification by using the membrane technology. So 500 kg batch we can do as one times. After the separation through the extractor, then we have the spray dryer also. Through the spray dryer, we have dry the material. So by using this method, we have developed this technology and transfer also. So this is the technology where by using the plant, this plant, we have extracted the oxyresveratrol molecule, and we got the 99% purity of this molecule after the purification of this molecule by using the membranes. So this is the zero waste membrane technology we have developed. This is the Octocorpus lacucha plant. Through that plant, from that plant, we have extracted the material and the molecule we required, that is the oxyresveratrol, we have extracted, then purified by using the membrane technology. And this technology has been developed, and the waste material also, whatever has been remaining, we make the composite board and the fuel briquette for that. So zero discharge has been happen here, and this technology has been developed and transferred. Second one is the natural dye. As you know, people are using the synthetic dye in the edible things, but we have extracted this natural dye by using the plant source, and after that purified by using the membrane, make it crystallize by using the dryer, and it's crystalline dry we have purified dye we have extracted, and this technology also we have developed and we have transferred this to the Navrin Enterprise Limited, Guwahati, and now they are producing these dyes and oxyretroviral also we have transfer. So these two technology here already people are means we our as an institute we have transfer and people are producing this material and is available in the market. Now the another technology we have transfer when I was in South Korea there. Also here I am working on that, but is still not transfer on the gas separation. So this is the gas separation technology. As I told, the flue gas having the CO2, N2, water vapor is the major defect here. Then the O2, SOx, NOx, then the hydrogen fluoride and HCl. Temperature also fuel gas is the 50 to 180 degrees Celsius. So how membrane technology work here? So we have targeted the water vapor and CO2 removal by using the flue gases. So now why we have taken this example? As the flue gas, you can see here the cooling tower having the flue gases, and why this as the gas there is no color, but why it looks the white color because of this water vapor and different cooling tower having the different concentration of water vapor are present. So to remove this, because of this water vapor present in the flue gases, the density of the gases has been enhanced, and these gases are nearby the surface of the earth. So as you see, the industry area is highly polluted, and there corrosion is the major issue and health is the another major issue. So that's why whenever these industries are located nearby the city, so we can implement the membrane technology for that. So we have directly taking the example here. Now you can see if you have the power generation power plant. Suppose the 700 megawatt power plant is there. So it requires 7,600 cubic meter per hour of the water, and out of which 1800 cubic meter per hour of water is evaporated and released in the atmosphere. It means how much tremendous amount of water has been going in the environment without we have recollecting it going in the environment, and for that the gases density has been enhanced, so that particular area has been polluted and giving the bad smell also, and corrosion of these buildings material and other material has been happening, so that industrial area facing the lot of problem. So what we have done, so to for the considering the environment point of view, to save this water, to protect the environment, so we have captured this water vapor by using the membrane technology, and also we have reused this water again for the industry. So here I worked in the SK Hannam power plant having the 400 megawatt power plant capacity, and we have made the curtain type of membrane module and implemented on this cooling tower upper layer of this Hannam power plant. So what generally industry use? They use the conventional type condensation technology. It means the water vapor, those are going in the flue gases, they try to capture it by using the condensation technology. But up to the 30% can be captured by using the condensation technology. It means 70% has been going to the environment. But when we tried to implement the membrane hybrid technology, we found that up to the 65 to 70% we are able to capture this water vapor from this flue gas. It means we save the water and save the environment, which has not been polluted, and water is also not loose. So we have up to the 70% of this water we have saved by using the membrane technology. So for that we make the curtain type of membrane module and implemented here on the upper layer of this cooling tower. And these are the results for that you can find here. Up to the 7% removal of this water vapor, it means 3,360 cubic meter per day we have saved. So the recovery ratio was very high. So industry required less water as they are not losing the more water through the environment, in the environment. So accordingly, second technology we are also implemented in the Asia Paper Manufacturing Company. Here 6 months I worked, and in this industry we found that the recapture water is highly purified water by using this membrane technology. And here we use this curtain type of membrane module. This is fabricated in our laboratory. We have coated the membrane module, and after that, we have implemented this structure on the above surface of the cooling tower, make the double layer structure and implemented. So this water we have captured by using this membrane technology. Also, in the North Institute of Science and Technology, our group is working on the such a kind of work to remove the CO2 from the off gases. So we got the big project from the Numerical Refinery Limited, that is the 90 crore. In 2024, the project has been started, that is inaugurated by our Honorable Director General, Dr. N. Kalaselvi ma'am. So we are the four scientists having the four different vertical here. As I am looking for the vertical number 1, that is the sustainable nanocomposite membrane for the CO2 capture from the PSA of gas. Here my responsibility is design and prepare the high performance CO2 capture membrane as well as fabrication of modules. So I am implementing the spiral wound module as well as the curtain type of membrane module. So this work is going on in continuous mode of operation, but still we have not implemented on the directly industry because our main goal is to implement this membrane technology in the Numerical Refinery Limited, Assam. So for that we received the 46 crore rupees at the 5 years targeted for our work, and first year now currently we received the 15 crore rupees. So we are working on that, buying the equipments, and laboratory repairing work is also going on by using this fund. So coming 5 years we will implement this technology in the Numerical Refinery Limited. So basically currently what we are doing nowadays, we have started our work with the industries only. So we call the industry people, make the interaction with the industry, and listening their problem, what they want, and accordingly by using the membrane technology along with the nanotechnology, we are giving the solution to them to find their problems and giving the solution for their problems. So for that, we have started the Center for Petroleum Research with the help of the Petroleum Ministry, where they have given us the 5 crore rupees, and now the industry also supporting us. So I am also the faculty of the Center for Petroleum Research in North Institute of Science and Technology. So our regular meeting with the industries are going on to solve their problem, also develop the technology and transfer to the various industries. That is the major goal that we are looking. As beside that, we are and in the academy also. ACSIR giving the degree to the PhD students. So we are enrolled there as I am the associate professor there. So under that, 8 students working under me in the PhD, and they are doing the very nice work because their work, then we are going for the large scale. So they are producing the good publication also because as you know, the student required the publication for their PhD course as well as to getting the jobs also. So they are working hard in our laboratory, and in the several area they have published very good results. So these are my students. Recently, 3 students have completed their PhD, and 3 of them got the good position. One, Dr. Sachin Karki, he went the Queen Mary University, London. Last month he joined, and in the May, the Dr. Diksha Yadav, she joined in the Purdue University, USA as the postdoctoral fellow. And the third student recently he graduated, so he is going to as a I issued PDF at IIT Kharagpur, West Bengal, India. And currently the 5 research scholars, they are working as a PhD scholar in my group. And this is our group also, the membrane researcher, other than my students also, other are working for the membrane separation and purification. And finally, I want to conclude my today's brief discussion about the membrane science, having acknowledging our director, Dr. V.M. Tiwari, who is leading this laboratory. I thanks to him as well as our HOD and group leader of the Chemical Science and Technology Division as well as the Chemical Engineering Group. My students and my collaborator, the funding agency where I got the money from the CSIR, DST, DBT, DRDO, Ministry and industry like NRL and BPCL. Professor Manisha Kodape ma'am, who have given me chance to present our work in front of you as well as interact with you people. Also the team UGC, MMTTC, Santagadgi Baba Amravati University Amravati. And thank you everyone. And also invited you, all of you, if you get chance to come to visit Northeast, particularly our institute says Northeast of Science and Technology. Also, we are open for the collaboration as well as if your student after graduating, they want to do the PhD, they can come here, join our project and enroll in the PhD for the ACSIR and they can continue their PhD work. Also, those have the JRF or the medalist of the industry, gold medal of the university. So directly he can enroll for the PhD and start the research work in our institute. So thank you all. Now you can ask me whatever if you want to ask anything.
Thank you, sir. I have a question. I have a question.
Hello.
Hello, sir. Am I audible? Yeah. What is the diameter of the hollow fiber, sir?
Yeah.
What is the diameters of the hollow fiber?
Hollow fiber diameter, there are the three different diameter we have used. 1.2 mm outer diameter and means 1.2 mm, 800 micrometer, then the 400 micrometer. So three different kind of diameter we can use. We have the three different spinning roll with us, so we can fabricate it.
Yes, sir. Now you were talking that you are doing the inner wall membrane, that separating membrane. You are coating that. So how is that coating that interface with that coating in the inner membrane in the this brand?
Madam, can you explain one more time? Can you loudly speak?
I'm asking what is the procedure for the inner coating of the hollow fiber?
Okay. So for the inner coating hollow fiber, we after the fabrication of the hollow fiber, we make the module. Okay, and we have developed the coating technology. So that instrument I have not shown, but I am telling you. So in the inner, once the hollow fiber bundle has been done and module has been fabricated. One more. Give me 1 minute. I will show you the module for that. You are seeing this slide now, hollow fiber membrane and module. Are you able to see the slide?
Yes, sir.
So suppose you can see here the HFM membrane module. So in the one side, because these are we have opening the four center here. One to pass the feed solution and another one is the permeate those pass through the membrane. Okay. So while coating also we block these two end. Those are the permeate side we have given. So directly inner side we can pass the solution for that by using the pump. So the aqueous phase monomer has been absorbed by the membrane. Then we apply the nitrogen for that. So means the water droplet or if water molecule present there. So through the nitrogen we are removing that one, and then we are passing, if the deep coating is there, then the acyl chloride monomer through the membrane. If that is the vapor phase, then we are passing the vapor through this side inside of the membrane. So we can get the crossing structure on the surface of inner surface of the membrane.
From the outer side, what solution you are passing? From the outer side, the permeate side, what type of solution you are passing?
No, permeate side means actually you are asking me first question. You asked me about the coating of that. Okay, now
Yes,
if we are taking after the coating has been done, okay, then we are giving the heat treatment for that hot nitrogen molecule, nitrogen gas we are passing, or we are putting the module in the oven to get highly crossing structure, that is the stable structure on inner the surface of the membrane. Okay. After that, membrane module formation has been done, membrane coating has been done, then we are implement for the application purpose. So then for the gas separation we required, then the gas molecule, whatever flue gas we have, we can pass through the membrane, and permeate side we will get the purified gas.
That
According to the
I
selection
can
process.
understand, sir. Sorry, sir, that I can understand. But actually, you are that phase inversion. How the phase inversion done? That you have shown that in the boundary, in the connecting phase, membrane is forming. So there should be one solution should be in the inner side and another solution should be in the outer side. That's after that in the interface area, the membrane should be formed. So that is why I am asking, in the inner side you are passing the membrane solution. So for the phase inversion, what type of solution you are passing from the outer side?
No, why
So
here madam, listen. This is the coating. We are discussing coating. If we are asking me the fabrication method, phase inversion, that is the water as the phase inversion. Okay, water is the solvent for the phase inversion. In the membrane fabrication, okay, not a coating.
Okay, sir. Okay, sir.
So here in this tank, if you see this one, the hollow fiber having, this is the tank now. So here is the dope solution, and after that here in the coagulation board for the phase inversion we are using the water. Okay, and for the pore formation if we need the dense structure, then we are incorporating the surfactant and other things in the phase inversion bath.
And then for the polymer, which type of solvent, NMP or chloroform, which solvent you are using?
NMP.
Thank you, sir.
NMP.
Yes, sir. Thank you, sir. Very nice presentation.
बगल वाले रूम में देखो ना, तो कहीं गए होंगे दूसरे किसी डिपार्टमेंट.
Yeah, is there another question so we can discuss?
Yes, sir. One question I have.
Yeah.
Sir, what about the metal organic framework we can use in this membrane as a nanofillers?
Yeah. We can use any kind of metal organic framework, MOF. As I told, we have used the EYO66 NH2. And nowadays also we are using the different zirconia based material, MOF material for that. But particularly we want the functionalized material, MOF material, having the amine as means pre-amine NH2 group should be there. So we have to functionalize that one, and then we can implement it for the fabrication of the membrane.
Actually, sir, I am working on packaging thin film membrane type work. Sometimes chitosan and cellular nanocrystals, we make the film with help of casting blend technique. And that film we are using permeation, oxygen and sometimes, sir, can we do such type of work with you with collaboration? My work, how will be associate with your work? Is there any idea? Actually, we have no sophisticated lab. Actually, what membrane type you are working, lab should be very sophisticated.
Yeah, you are right. So as already I told, we are always open. I am also always open to collaborate with you. Whatever facility or any help you require, so we can discuss separately, and I can help you and provide the facilities also. No problem. Whatever we have.
Okay, sir. Thank you. Thank you very much, sir. Nice presentation, sir.
Thank you.
Yes,
a small question because in case of gas separation, the defect is very crucial. So how are you dealing with this defect free membrane? Is there
Madam,
are you facing any?
madam, there was another noise. So can you tell one more time? Madam, can you ask one more time?
Dr. Priyanka, ma'am, I think there is some background noise. What you can do, if you can ask clearly with the question, or you can put in the chat box.
No, she can ask one more time. Actually, I
Yes.
am not.
Yes, sir. Sir, I just want to know how are you deal with the defect of the membrane, because a defect is a major problem in gas separation.
Right, right. You
So
are
how
right.
are you deal with that?
Yeah. So, madam, yeah, it's a nice question because always gas separation we have to consider to make the defect-free membrane. So for that, that's why I'm telling you, mixed matrix membrane, if you have fabricated as 20 years I'm working in this particular area, so you will get defect on the surface of the membrane. But if you have the knowledge about how to fabricate the thin film composite or thin film nanocomposite membrane, so you will not find out any pinhole on the surface of the membrane, and that membrane is giving the very good results. Also, if you have the problem is not getting the good thin film nanocomposite layer, so you make the PDMS coating on that first, and then make the thin film nanocomposite layer or composite layer on the surface of the membrane.
Okay, sir. Thank you. Thank you so much. Sir, I will contact you later for any type of help or in collaboration.
Yeah, sure, madam. Any type. Sorry, no problem for us. Definitely, you can contact.
Thank you, sir. Thank you so much.
Yes, anyone else? Anyone else has any questions or the queries? If not, then we can conclude. Sir, I think there are no further questions. So if you could permit, shall we conclude, sir?
Yeah, definitely.
So on behalf of Malvi Mission Teacher Training Centers and Gadge Baba Amravati University, I extend my sincere, and all the participants, I extend my sincere thanks to Professor Ingole sir for such a wonderful session. Rather than his busy schedule, he has provided his spare time and thought-provoking session here and elaborated their efforts uh, towards this very important aspects. And so really, we are thankful to you once again for this much important aspects you have provided here. And definitely, the participant forum is open for collaboration. You can approach to Professor Ingole sir for your futuristic research also. So with this, I once again extend my sincere thanks to Professor Ingole sir, and with the kind consent of Professor Ingole sir, I would like to declare that this particular session will be over here. Thank you, sir. Thank you so much.
Thank you so much, sir. Thank you.
Thank you. Yeah, thank you, everyone. Thank you, madam.
Thank you.
Okay, so participants, now we will continue our next session sharp at 12:15. Till that, there will be a break. Thank you, sir. Thank you.
Thank you.
Thank you.
Okay, sir. Thank you.
Continue. शुरू से चलो 3 मिनट है. Hello, Manisha. Hello, Manisha.
हेलो मैडम, नमस्ते. हेलो.
वेट करो. हेलो.
हेलो. हाँ
ऐकायला
मैडम,
येतो माझा माझा
येतो आहे.
हा
येतो आहे आवाज.
हॅलो येतो ना ओके.
हाँ. नमस्ते मैम.
नमस्ते 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 कैसे हो.
How are you? How are you, ma'am?
फाइन फाइन फाइन. चलो
Very happy to see you, ma'am.
या टू यू ऑल्सो थैंक यू. ऐसे याद करते रहो हम आते रहेंगे. अब तो हम रिटायर है.
Yes, ma'am.
My screen is visible.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes yes yes. चलो. ए,
Dr. Ganesh Thorat.
Yes, madam. I'm
Okay.
audible.
You are there? Okay.
I'm
Madam?
audible, madam.
Yes, yes, you are audible.
Okay.
Madam, shall we
Myself.
start?
yeah. I'm ready.
Okay, ma'am. Okay. Yes, Dr. Ganesh, sir, please.
Okay, madam. Thank you. Myself, Dr. Ganesh Deolal Thorat, Assistant Professor, Sri Shivaji Science and Art College, Chikli. It is my privilege to introduce Dr. Mamta R. Lanjewar. Dr. Mamta R. Lanjewar is a distinguished professor of physical chemistry at Rashtra Santa Tukaroji Maharaj, Nagpur University, Nagpur, with an extensive academic and research career spanning several decades. She completed her BSc 1987 and MSc 1989 from Amrata University and earned her PhD from Nagpur University in 1995. She has rich teaching experience, including 18 years at Sri Shivaji Science College, Nagpur, and over 13 years at the Department of Chemistry, RTM, Nagpur University. Her research expertise lie in nuclear and radiation chemistry, material science, and environmental science, with significant work in neutron activation analysis, radioanalytical technique, and nanocomposite material. She has contributed extensively to scientific literature with over 65 international and 7 national research publications, along with conference, presentation, and invited talk. Dr. Lanjivan Madam guided several PhD scholars and completed 100 research projects on nanocomposite and environmental remediation. She has also served in a key academic and administration role, including Senate member of RTM Nagpur University and board membership in various institutions. Her international exposure include research to visit to Tokyo Metropolitan University and conference participation in China. She has received numerous accolades such as the National Merit Fellowship, Best Teacher Award, and Lifetime Achievement Award at NCISA 2026. Additionally, she has actively contributed to the scientific community through organizing conference, editorial role, and membership in prestigious scientific associations. I'm warm welcome Dr. Lanjwar Madam. I warm welcome. And also thanks to course coordinator Dr. Manisha Kodapi Madam, Department of Chemistry, Sant Gadgibab Amravati University, Amravati, to give me chance to give me opportunity to introduce today's resource person. Thank you, madam. Thank you.
Thank you, Ganesh sir, for your kind words. Okay, madam, should I
Thank
start
you,
now?
madam.
Yes, ma'am. Yes, ma'am. Please.
नाही जाणार मला दिसणार नाही हॅलो मी दिसत नाही
Yes, madam.
Yeah, I'm audible.
Yes,
Okay,
ma'am.
so first, I'm very much thankful to Professor Kodape madam for inviting me as a guest speaker, and I'm also thankful to all the participants. Okay, good afternoon to all. My topic of research or today's lecture is nuclear analytical techniques, neutron activation analysis, and isotope dilution analysis for environmental analysis. Friends, you know that nowadays environmental analysis is the burning topic, right? Everyone is talking about the environment, that is the water pollution, air pollution, soil pollution, and so on, right? So for this one, the very important thing is that you should analyze whatever the topic, whatever the constituents are there, what are the pollutants are there for by different techniques. Now, as far as my technique is concerned, it is somewhat what I can say is that the very prestigious or very accurate and precise. Okay, somewhat costly is there, but at the same time it is very accurate and precise, right? So let us start with the introductory part and then see what this neutron activation analysis mean and isotope dilution analysis mean, right? So for being it is the nuclear techniques, first I will deal with the very basic things regarding the nuclear analytical techniques, or the as far as the nuclear array, rather to say all are the teachers. Now you people all are the teachers. So okay, so you definitely know it, but for dipping into my topic, okay, I think that some basic things should be recalled so that it will be much easier to understand the topic. Actually, the topic neutron activation analysis, that means it is the activation analysis, but whatever the samples are there, whether it is the water sample, it is soil sample, whether it is the dust particulates, okay, that will be activated by neutrons. From where this neutron comes, how they come, and what analysis we are doing, that we will see later part, right? And isotope dilution analysis. Here also you all aware of the radioisotopes. So that isotope will be diluted and the analysis will be further done. Okay, and we are able, with this technique, we are able to analyze the samples up to in 1 milligram of the samples, we are able to analyze up to 60 to 65 elements, and that to up to ppm and ppb level. Okay, so now let us start. So as far as the introduction is concerned, as I have told you already, that increasing industrialization and urbanization, including technological advancement, vehicular traffic, and use of fertilizers, pesticides, detergents have grossly contaminating our environment. And it is a burning problem nowadays, all you know, and you agree with me, right? Many mineral, metallurgical, and chemical industries release heavy metals which are toxic in nature. Day by day, पूरा सब इधर उधर सब इंडस्ट्रियल एरिया हो रहा है, राइट? सो उसके कारण से पूरा हेवी मेटल्स इसमें आ रहे हैं environment mein. Okay, so many mineral and metallurgical chemical industries, they release the heavy metals which are toxic in nature. Biochemical studies have shown the harmful effect of toxic heavy metals such as barium, chromium, copper, cadmium, mercury, thallium, and lead, and so on. Several diseases have been attributed to excessive exposure of some toxic metals and their specific compound, which show detriment mobility in the ecosystem. Okay, heavy metals, anyhow, they will enter into the environment and they will cause the several diseases. You agree with me? In order to understand the subtle consequences of the chronic low-level exposure of heavy metal, it is essential that suitable method should be developed for their determination at low level up to nanogram per gram and specific matrices. It is very much required that whatever the heavy metals are there, their chronic low level exposure of heavy metals, it is essential that they should be determined up to, or they will be determined up to nanogram per gram and with specific matrices. All possible sources of metal pollution, such as combustion of fossil fuels, municipal waste, incineration, industrial processes, producing wastewater, and emitting pollutants in air, transport, the agriculture use of sludge, and all kinds of waste disposal need to be investigated, starting with an elemental analysis of materials involved. Before meaningful conclusions can be drawn concerning sources, pathways, and environmental impact, large number of acute analytical data are required. Nuclear analytical methods such as neutron activation analysis and radio tracer methods are the most powerful and widely used techniques. Okay, so this is what about the what is called as the background or the necessary for the introduction of my topic. Okay, now this is about why it is required, right? Now let us come to the what this neutron activation analysis is there, okay, and how it can be performed, or how the elemental concentrations can be calculated with precisely and accurately with the help of these techniques. Okay, so न्यूट्रॉन एक्टिवेशन एनालिसिस टॉपिक समझने के पहले आपको कुछ फंडामेंटल कंसेप्ट रिकॉल करनी पड़ेगी. I have told you that all of you are the teachers, right? So naturally you know it, but being the new topic or new technique, maybe because nowadays nuclear लोग से ही घबरा जाते हैं. न्यूक्लियर का एक ओके सबसे पहले दिमाग में आता है एटम बॉम्ब, राइट? एंड देन बाकी और सब इसमें ऑफ कोर्स हर एक चीज के एडवांटेज है एज वेल एज डिसएडवांटेज है, लेकिन with these techniques it is very useful and all that one. I will come to that point at the end of my topic. Okay, for understanding of these techniques, how to recall all these things. First is the nucleus. You have to a little bit idea. You have the radiation nucleus. Then what are nuclear radiations? Neutron classification, nuclear reactions, neutron sources, nuclear reactor schematic, neutron flux, neutron capture cross section, and neutron activation radioactivity. Okay, these are very simple, but at the same time all these we require for as far as the calculations are concerned, as well as the application of this technique is concerned, right? All are know you are there, that material is there, maybe environmental, maybe biological, maybe medical, and all that one, right? So material contains compounds, compound contains elements, and elements ultimately give the atoms. Okay, so atoms के अंदर में neutrons and protons है, और electrons are revolving around the this one nucleus. Now element X, these are the terminology, you know it, very simple, even 10, 12 school going students know it, but it will require because the symbols are there, right? So element X can be depicted by A as mass number, and neutron number, and Z atomic number, or it is also called as proton number. So A is equal to Z plus N. This is how we can represent the element X with mass number and a neutron number and the atomic number, right? Now the nucleus charge, न्यूट्रॉन का चार्ज होता है 1.008665. okay, no electrical charge is there. Mass, sorry, न्यूट्रॉन का मास होता है 1.008665, no electrical charge is there, as you know. Proton 1.007277, okay, it positive charge is there, and electron mass है 0.000548, this one, okay, negative charge is there. You are aware of this one, right? Now as far as the nucleides are concerned, the terms isomer, isotope, isobar, and isotones are there. These are again you are aware. Isomer, we will shortly recall it. Isomer, that is the same Newtonian number Z and A, but A atomic of this one, but exist in an excited state for a period of time. For example, this cobalt 60, okay, half life period है इसका 5.27 years, and cobalt 60 meta, it is half life is only 10.48 minutes. Then isotope, same Z number but different N number. Okay, cobalt 32 and with this one 59, and cobalt 60 with atomic number this 32 and 33. Then isobars, same A number but different Z. Okay, examples are there, cobalt and nickel. Then isotone, same N number, different Z and A. Okay, and these examples are this iron, cobalt, and nickel. These are very basic things. Now, nuclides are there. Now, these nuclides can be classified into radioactive and stable. Then radioactive may be further classified as artificial and natural. Now, third point that we are dealing is that radioactivity, that is the nuclear radiations, right? Radioactivity is proposed when unstable nuclei decay. For example, the slow decay rate of primordial heavy elements such as uranium and thorium, right? The radioactive daughter products which form during natural radioactive decay series of uranium and thorium. Third, the irradiation of stable isotope with particles generate unstable isotopes which decay to stable isotopes by emitting radiations. Neutron activation is important in this regard. As far as our topic is concerned, this is very important, that irradiation of the stable isotope with particle generates unstable isotopes which decay to stable isotopes by emitting radiations. Neutron activation analysis is important in this regard. Particle bombardment of fissionable elements leads to unstable fission fragments. The disintegration of radionuclides releases excess energy in the form of nuclear radiations. This radioactive decay takes place in several ways, emitting radiations such as alpha rays, beta, that is the negative and positive rays, gamma rays, neutrons, neutrinos, proton decay, internal conversion electrons, characteristic X-rays, and fission fragments. Gamma and beta play important role in neutron activation analysis. Gamma rays are emitted when an excited nucleus de-excites by the transition from an excited energy state to a lower energy state. Gamma rays have well-defined energies and their emission often is accompanied by nuclear reactions and nuclear decays. Okay, as far as this neutron activation analysis is concerned, this gamma rays, emission of gamma rays is at importance, right? Of course, beta and alpha is there, but major contribution is due to this gamma rays. Negative beta particles or negatrons are emitted when neutron is transferred into a proton during the nuclear transformation. Negative beta particles are electrons formed during nuclear transformations. Hence, are of nuclear origin. The atomic number Z of the resultant nucleus is 1 unit greater, but the mass number is unchanged. Now, as far as the neutron activation analysis is concerned, according to analysis, okay, which type of sample we have to analyze, okay? For that, we have to choose the neutrons, and neutrons are choose or they are classified depending on their energies, okay? So neutron classification according to their kinetic energy, type of neutrons and energy. Thermal neutrons are there which have the energy 0.025 electron volt. After that, the epithermal neutrons are there which have the energy 0.025 electron volts to 0.25 electron volts. Then resonance and neutrons are there. They have the energy 1 electron volt to 1000 electron volt. Then intermediate neutrons are there which have the energy 1 keV to 500 keV, and the fast neutrons are there which have the energy more than 0.5 MeV. So depending on the samples, which samples we have to analyze, okay? So you have to use that type of the neutrons. Now, next point is nuclear reaction. Nuclear reactions occurs when target nuclei are bombarded with nuclear particles depicted pictorially. This X plus A. X is target nuclei. When it is bombarded by the nuclear particles A, you will get Y plus B plus Q, or simply depicted as X in bracket A, B and Y. Y is the target, X is bombarded by particle A, Y is the product nuclei with resulting particle B. Now, as far as the nuclear reactions and simple chemical reactions are concerned, okay, there is a difference of energy. Where in simple chemical reactions, we have write down A plus B changing to C plus D. Along with that del V, that is the whatever the reactions, whatever the energy involved there, right? Enthalpy, entropy, whatever the energy has, the del H value is there, right? Here, instead of this one del V, we have the called as the value Q value, and there is a tremendous difference between the as far as the energy is concerned in case of the nuclear reaction and that of the chemical reaction. And this Q value is nothing but it is the difference in masses of the products and that of the target as well. So Q is the energy of nuclear reaction, which is the difference between the masses of the reactant and the product. For example, this cobalt plus when it is bombarded with this neutron, you get cobalt 2733 along with the emission of the gamma rays. And pictorially, it is represented in this way, right? Now, next point is neutron reactions. When target nuclei are bombarded with neutrons of the possible nuclear reactions that can take place in 4 reactions. Okay, when that target nuclei are bombarded with the neutrons, okay, of that particular energy, the possible nuclear that can take place in 4 major reactions. First है neutron capture, second है transmutation, third है fission reaction, and fourth is inelastic scattering. Now, what this neutron capture says that the target nucleus absorbs or captures a neutron resulting in a product isotope, the mass number of which is incremented by 1. If the product nucleus is unstable, it usually de-excites by emission of gamma rays or beta rays. Okay, example is given here that iron, when it is bombarded by neutrons, you get iron 59, iron 58. When it is bombarded with neutrons, you get Fe 59 along with the emission of the gamma rays. Then next comes the transmutation. Target nucleus absorbs a neutron emitting charged or non-charged particles like alpha, protons, or 2 neutrons, neutrons or deuterons. The unstable product nucleus generally de-excites through beta emission back to the target nucleus. Okay, transmutation, neutron activation, or neutron reactions are caused by neutrons of high energy, fast or intermediate, and that's why initially I have shown the how that neutrons are classified depending on their purpose. They will be classified, okay, and they are be used. Then fission reaction. Fissionable target nucleus, usually atomic number Z greater than 90, absorbs a neutron, triggering the fission process, splitting into large segments and simultaneously releasing 2 to 3 neutrons. The fission process can become a chain reaction, producing large amount of neutrons, which becomes source of the nuclear reactor. This fission reaction is very common, or rather it is the source where they're in the nuclear reactor. Okay, as far as this one is concerned. Now, last fourth is the inelastic scattering. Target nucleus does not absorb the incident neutrons, but only part of the neutron energy is transferred to the target. Now, what are the neutron sources? ये आते कहाँ से है? Okay, so major sources are nuclear reactor, fast neutron generators, cyclotrons, isotopic neutron sources. Okay, these are the four major. This one, maximum nuclear reactors are at BRC, as you know, Bhabha Atomic Research Center, Apsara, Cyrus, Dhruva, right? One of them it has Kalpakam. Then, as far as the fast neutron generators are concerned, the cyclotrons are concerned, they are at Calcutta. Then isotopic neutron sources are concerned, that our university, Nagpur University, is lucky. Okay, we have the americium beryllium source. Okay, though the strength is less, but it is there. That facility is there in whole of the Vidarbha in our department. Now, let us come to the nuclear reactor in brief. Okay, पता चलेगा कि न्यूट्रॉन्स आते कहां से है और how it is produced, right? Uranium, thorium, and plutonium are fissionable materials with radioisotopes: uranium 33, uranium 235, uranium 238, thorium 232, plutonium 239, plutonium 241. Fission is triggered when a fissionable target nucleus captures thermal or fast neutrons. This neutron reaction splits the target nucleus into two lighter nuclei, and average of 2 to 3 neutrons is emitted in case of uranium 235 by thermal neutron bombardment. The first fission process may trigger second fission reaction when one of the neutrons emitted is captured by the another fissionable nucleus, and this process in turn trigger a third one. मतलब एक के बाद एक chain reaction. That's why it is called as the chain reaction, and so on, thus capturing a chain reaction. That is, uranium 235 has 0.712% isotopic abundance. Now, what this abundance is? Abundance is the atom percentage of an isotope present in the mixture. So reactor components में क्या क्या होता है? एक component है, material है, पर function है. एक तो fuel है, fuel uranium 235 for example, moderator, light and heavy water, right? Carbon and beryllium. Then to reduce the energy of the fast to thermal. Okay. Then coolant will be required, light and heavy water, right? To remove the heat. Then reactant shielding, same as that of the moderator, to reduce the leakage, right? Then shielding is there, concrete, water, right? Steel, polythene, and all the polyethylene and so on, to provide protection from radiation. Then control rods, cadmium, barium is there, control the reaction product rate, and the structure, that is the aluminium, steel, and zirconium, to provide the support. So this is in short or in vague sense the reactor components and materials are there and functions are there. This is how the schematic diagram of the reactor, okay, in short, right? So these reactor containers are there, then control rod are there, fuel plates are there, primary coolant are there, okay, then primary shield is there, circulator is there, then secondary coolant is there, heat exchanger are there, and the secondary shield is also there, okay. Now, after this one, we come to the next point of that list, that is the neutron flux. Neutron flux is the amount of neutrons available for irradiation. The unit of neutron flux is the number of neutrons per square centimeter area per second. Okay, neutron per centimeter square per second. Thermal neutron activation analysis required at least a minimum neutron flux of 10 raised to the 9 to 10 raised to the power 10 neutron per centimeter square per second. The neutron flux 10 raised to the power 11 to 10 raised to the 13 neutron per centimeter square per second can be generated by research reactors of total power 100 to 200 kilowatt. The irradiation time for neutron activation analysis depends on application. Which type of samples you have to analyze, depending on that one, okay, you have to irradiate the samples. Or you have to choose the irradiation time. Then neutron capture cross sections. Neutron activation occurs as a result of interaction between incident neutron and the target nuclei of an atom. the radius of a typical atom is of the order of 10 raised to power minus 10 meter. And that of nucleus is 10 raised to power minus 14 meter. And that of neutron is 10 raised to power minus 10 meter, minus 18 meter. The probability that such interaction to take place for a nuclear transformation to occur depends on the energy of the neutrons, and the nature of target nucleus is referred to as neutron capture cross-section of the isotope leading to a specified nuclear reaction. The neutron capture cross-sections are expressed in units of area in bars, where 1 bar is equal to 10 raised to power minus 24 centimeter. Next point is neutron generators. Neutron generators typically generate fast neutrons. The target nuclei of deuterium or tritium, when bombarded with deuterium ions, the neutron interaction generates fast neutron flux of energy 2.5 MeV to 14 MeV respectively. Then cyclotrons. The involved neutron reaction is beryllium 90. This one, and we get the boron 10. The neutron flux of 10 raised to power 10 to 12 neutron per centimeter square gets generated. Then isotopic neutron sources are there. Californium source is there, that is kept at Pune University, but now it is almost decayed. No one is taking care. Okay. Then polonium beryllium source is there, radium barium source is there, and we have at our place we have the americium beryllium source. Then nuclear analytical techniques. Okay. Broadly, they are classified into two parts, that is direct methods and indirect methods. Now, direct methods में आते हैं measurement of radionuclides in the system, then measurement of natural radioactivity, measurement of artificial radioactivity. Then indirect methods में आते हैं activation analysis, particularly of us, okay, which we are dealing. Okay, now this activation analysis further classified as prompt and delayed. Then this particle induced X-ray emission is there, gamma coincidence counting is there, proton induced proton spectroscopy is there. So many techniques are there, right? This delayed activation methods may now this techniques comes, that is the neutron activation analysis, charged particle activation analysis, and photon activation analysis. Okay, other number of methods are there, number of so many techniques are there. Okay, but now due to time constraint, we are talking with this neutron activation analysis in detail. Now let us come to our actual technique introduction of this one. The analytical chemists are always in search of methods of elemental analysis which are accurate, precise, specific, fast, and universally applicable. Then that means whichever the technique you are using, that must fulfill all these five criteria. It must be accurate, it must be precise, it must be specific, it must be fast, and it must be universally applicable. Activation analysis is one such analytical technique which fulfill all the above criteria. Neutron activation analysis was invented by George Devan Hevesy and Hilde Levy in the year 1936. Okay. Professor George Devan Hevesy was awarded Nobel Prize in Chemistry in 1943. Just see the chronology. Okay. The technique was invented in the year 1936, and just after 7 years, Professor Hevesy was awarded the Nobel Prize for this one. Okay. Now let us come to the principle of this one. Activation analysis is based on principle of interaction of nuclear particles such as neutrons, charged particles, or photons produced in nuclear reactor or particle accelerator with the elements of materials to be analyzed. As a result, radionuclides are formed. The interacting particle is neutron. It is called as the neutron activation analysis. Okay, that means simple incident neutrons है, टारगेट न्यूक्लियस है, जो भी आपका सैंपल आपको एनालिसिस करना है, एनवायरमेंटल है, मेडिकल है, बायोलॉजिकल है, व्हाटएवर इट मे बी, ओके, सो इट इज bombarded with the incident neutron. As a result of this, you will get compound nucleus. Then that compound nucleus will be excited state. It will emit the prompt gamma rays. Then this compound nucleus will decay to radioactive nucleus. Okay, it emits the beta particles, delayed gamma particles, and after that you leads to the product nucleus. Okay, this is the schematic flow sheet of the neutron activation analysis. What is exactly happening? Whatever the samples are there, that samples we have to irradiate with the neutrons which are available in the nuclear reactor. Okay, as a result of this, we will get the different elemental concentrations, that these different elements, okay, and that different elements, they have their own energy as well as the of course in the activated state, okay, as well as the half-life. That is the important criteria for that one. Now, I have gone through this one, that depending on the energy of the neutrons, they are classified as thermal neutrons, epithermal neutrons, fast neutrons, and relativistic neutrons. Okay, आपको कहाँ अप्लाई करना है, कौन से एप्लीकेशन से कौन से सैंपल एनालिसिस करने हैं, okay, उसके हिसाब से that type of neutrons you have to use. Of course, the control is there in the nuclear reactor. Various type of reactions occur depending on the energy of neutrons. Neutron capture or N-gamma reaction. Okay, the example is there. In the sodium is irradiated with this neutron, you get the neutron plus along the sodium along with the emission of the gamma rays. Okay, this is how neutron emission NP reaction are there, right? These are the example. And alpha particle reactions is there, emission is there, N gamma reaction example is there. Okay, these are the typical examples. Then inelastic scattering reactions are there. These are how they are depicted, right? And this is the example of this inelastic scattering. Then multiple neutron emission is there, right? This is the generalized way of representing it, and this is the specific example of this multiple neutron emission. Now, after the principle, let us come to the theory and equation. In neutron activation analysis, the sample is bombarded with neutrons producing an unstable radioactive compounds yielding radioactive species by N-gamma reaction. This is simple one, that होता क्या है यहाँ पे, जो सैंपल आपको एनालाइज करने हैं, that will be bombarded with neutrons, okay, that will produce unstable radioactive compound nucleus, okay, and yielding the radioactive species by N-gamma reaction. What N-gamma reaction, that we have already seen, right? Now N-gamma reaction से radioactive species जो form होती है, उसके लिए दो important criteria है in order to analyze it. One is its half-life and second is its energy. Okay, so each of the radionuclide has its characteristics property, its half-life, very important, the type of energy, then third is the timing of emitted radiations and the intensity of the emitted radiation. These characteristics properties can be used for qualitative identification and quantitative determination of an element, right? The rate of formation of the product nuclei depends on the number of target atoms and the neutron flux phi, neutron capture cross section sigma, and the time of irradiation Ti. Okay. Therefore, the total activity generated may be calculated from the basic equation of activation analysis. That is, A is equal to W upon M into I into sigma into phi, that is 1 minus e raised to power minus lambda Ti e raised to power minus lambda Td epsilon into 6.03 into 10 to the power 23, where this W is the concentration of the element in the sample. Okay, I is the fractional isotopic abundance, M is the atomic weight or mass number, lambda is the decay constant of the product nuclei, D is the delay time, and epsilon is the efficiency of the detection or counting system. Although the above equation may be directly used to obtain elemental concentration, this is not usually done due to some uncertainties in the cross section and effective flux density phi. Instead, a comparator method is used where a standard with known concentration of an element is always irradiated along with the sample under exactly identical condition, followed by counting on the same experimental setup. Okay, this is very important. Okay, basic equation we can use, but there are some limitations, that there are some uncertainties in the cross section and effective flux density. That's why instead of using the absolute method, we are using the comparator method. Now, comparator method, matlab the name itself suggests that whichever the sample you have to analyze, right? That should be matches, that matrix of that sample matches well with that of the which standard you are using. Okay, and of course I will come to that point a little later. Okay, that there are some standard agency that they will prepare that standard, and that standards have the same matrix that which you, of course the sample is unknown. We are not we are determining the elemental concentration. We are unaware of the elemental concentration of the sample, right? But some environmental samples are there, so accordingly that standards you have to use. Some biological standards are there, then you have to use that type of standards. If geological samples are there, then you have to use that type of standards. Okay, so instead a comparator method is used where a standard with known concentration of element is always irradiated along with the sample under exactly identical condition, followed by counting on the same experimental setup. If activity is so generated in standard W gram of the element A and two equations are compared, then A upon A, that is W upon W dash, or W is equal to W dash into A upon A dash. In terms of count rate, if R and R dash are the specific activity of the sample and the standard, then the concentration of element in unknown sample may be calculated as W is equal to W dash R upon R dash. That is the weight of element in standard into specific activity in sample upon specific activity in standard. Then comparator methods can be directly used for the calculation of concentration of element in an unknown sample, provided its concentration in the comparator method is known with certainty. Okay. Now, how these standards are prepared? Okay, what are these standards? Samples unknown है, अपने को elemental concentrations उसमें से determine करना है. So we must have the standard that have the what is called as the most authentic values. Okay, when we analyze our samples with that of the standards under the same identical condition, under the same counting system, then with डंकी की चोट पे अपन बोल सकते हैं कि हमारे रिजल्ट जो है दैट इज वेरी एक्यूरेट, राइट? जो स्टैंडर्ड्स के जो रिजल्ट्स है उसके हिसाब से उसमें जितना एलिमेंटल कंसंट्रेशन है उतना ही उसके हिसाब से जो अपने अननोन सैंपल्स है वो यदि कंपेयर करते हैं देन वी विल गेट द एक्यूरेट रिजल्ट्स ऑफ दिस वन. सो ये जो स्टैंडर्ड्स है ये कहाँ बना के जाते हैं? तो फर्स्ट तो है सिंथेटिक स्टैंडर्ड्स वी आर प्रिपेयरिंग इन आवर डिपार्टमेंट, राइट? सेकंड है सर्टिफाइड रेफरेंस मटेरियल CRM. ओके, नेक्स्ट है स्टैंडर्ड रेफरेंस मटेरियल SRM. These are very costly. Agencies for this one are National Institute of Standard Technology NIST Japan, NIST USA, IAEA Vienna, NIES National Institute of Environmental Studies Japan, Institute of Nuclear Chemistry and Technology INCT Poland. Okay, so ये जो है ये these are the different agencies which are preparing the standards. Okay, or they are not preparing by one method, and number of multiple methods are there. They are analyzing the same method, same sample by different methods, and then statistical analysis is come forward. Okay, by doing all these methods, all these standards analysis, okay, they come with the values, okay, all over the world. See, NIST USA is there, IAEA Vienna is there, then NIES Japan, that is the National Institute of Environmental Studies, that Japan is there, then Institute of Nuclear Chemistry, Technology, INST Poland are there. These are the very reputed institutions, and they are analyzing or they are preparing the standards by doing that various matrices of the samples are there. Then they are doing it by multiple techniques, okay, accurate and precise technique. And after the analysis of this one from all over the world, they are come forward with the values of the standards. That okay, iron will be here, barium will be there, copper is there, whatever the elemental concentrations are there. So now what we people are doing is that we are analyzing our sample which are unknown with that of the standards, okay, along with under the same identical conditions, under the same experimental setup. Okay, I am lucky that I was involved there in the sample analysis of Institute of Nuclear and Chemistry and Technology INST Poland. इनका जो सर्वे हुआ था इसमें I was one of the participants. Okay, they have sent the samples, have analyzed it, okay, and then they have sent the reports to them. Even I have visited to the National Institute of Environmental Study, Japan also. Okay, there also the n number of standards are there. They have prepared. Okay, and then I have visited their laboratory. Of course, I was not involved there, but I have used their standards for the analysis my samples. Okay. Then I got the fellowship from International Atomic Energy Agency, Vienna. Okay, for 3 years as a JRF and 2 years as a SRF. So we have the big project of 10 lakh in 1989 to 1995. Okay, such type of project, मतलब international project Nagpur University में directly अभी तक तो नहीं आया है, as far as the chemistry department is concerned. And I'm lucky, my guide, Professor N. Garg, he got that project, and I have worked there as a co-investigator. I'm lucky there, and I have worked most of the time there in BRC Atom Research Center. Rest of the thing we have developed in our laboratory, in the nuclear chemistry laboratory of Department of Chemistry, RTM Nagpur University, Nagpur. Okay. Reference material of a variety of matrices such as plant leaves, tissue or dust particulates, soils and rock powder are available. However, these are quite expensive. Then come to the classification of Na. Different factors required for selecting the activation reactions are suitable half-life of the activation products, availability of the neutron flux, absence of interfering reactions, and optimum sensitivity. Depending on these conditions, this neutron activation analysis can be classified as from gamma neutron activation analysis, thermal neutron activation analysis, that is the instrumental neutron activation analysis, cyclic neutron activation analysis, and the radiochemical neutron activation. Then epithermal neutron activation analysis, fast neutron activation analysis, and derivative neutron activation analysis. Okay, these are the reactions, energy, half-life, okay, and the neutron aids. Then different nuclear reactions are possible depending on the energies of neutrons. Okay, thermal neutrons induce N-gamma reactions. Most elements undergo N-gamma reactions, also called radioactive capture. Their cross-section sigma values are high and hence very useful for neutron activation analysis. Some examples are given here, that when the sodium irradiated with this N-gamma reaction, you get sodium 24. This aluminum, you get the half-life are given here. See, here is the half-life period given here. Okay, that in first case it is the 15 hours. In second case it is the 2.24 hours. In calcium case it is the 8.72 minutes. Okay, then in arsenic it is the 26 hours. Okay, then this, as far as the manganese is concerned, it is 2.58 hours. Okay, in iron it is the 44.5 days. Okay, indium is there, 25 minutes are there. Okay, and this gold is there, that is the 2.69 day. See, when we see the half-life of these elements or these nuclear reactions, okay, we come to know that it is not possible to catch all the elemental concentration at same time, because they have the different half-lives. Okay, उतने टाइम में उसको आपको पकड़ना पड़ता है. ओके, मतलब ये है कि ये आपका एलिमेंटल कंसंट्रेशंस, आपके पास आपके एलिमेंट्स में 40 एलिमेंट्स है फॉर एग्जांपल. ओके, 40 एलिमेंट्स में कुछ वेरी शॉर्ट लिव्ड होते हैं, कुछ इंटरमीडिएट लिव्ड होते हैं, मतलब कुछ मिनटों वाले होते हैं, कुछ घंटों वाले होते हैं, और कुछ डेज वाले होते हैं, और कुछ ईयर्स वाले होते हैं. और जनरली radioactivity will be generated for in order to generate the radioactivity. Okay, आपको उसको irradiate करना पड़ता है sample को, and that sample will be irradiated for that particular time of irradiation. Okay, depending on which elemental concentrations you are interested, right? And then depending on that one, depending on their radioactivity or half-life, okay, they will be counted accordingly. जैसे BRC में न्यूक्लियर रिएक्टर में यदि हमने सैंपल एनालाइज किया, राइट, और उसका यदि 25 मिनट्स ये है हाफ लाइफ है, या 10 मिनट उसका हाफ लाइफ है, तो वहां से नागपुर तक आते तो मर जाएगा, राइट? So what we people are doing is that we are irradiated our sample there itself in the BRC, in nuclear reactor. Okay, we collect there and we will use their radiochemistry division at BRC Bombay. Okay, for this short irradiation work, we frequently visited there. We have the access to visit there or stay there for 1.5 to 3 months. Okay, we collect the samples from nuclear reactor with our own hand. Okay, then we take it out and go there in the radiochemistry laboratory of BRC, this one. Okay, and then we analyze this short-lived radionuclides. As far as the days में जिनका ये है हाफ लाइफ है, या जो एलिमेंटल जिसके हाफ लाइफ है और जिसका एलिमेंटल कंसंट्रेशन हमको गिरना है, तो व्हाट वी पीपल आर डूइंग इज दैट, I mean, our samples will come by flight here at Nagpur. So in our project, 2 students are there, myself and one is Dr. Nitin Chutke. So from 24/7 counting is going on. So from रात को 10 बजे से सुबह 6 बजे तक that Chutke is working. Okay, and सुबह 6 बजे से रात को 10 बजे तक I will be working. So whatever the elemental concentrations are there, okay, in hours, that we can flight. We have the special assay. उस जमाने में 35 years back, okay, when I was working, रात को 8:30 बजे फ्लाइट आता था, वहां से immediately cargo sessions में we have the special assays that they will give immediately. We collect it and immediately आते थे डिपार्टमेंट में. डिपार्टमेंट में आने के बाद यहाँ पे that gents colleague of mine will come there 8:30 में, तभी एयर इंडिया का फ्लाइट आता था. Okay, or then I will be ready here with all the setups and all that one. We unpack that samples and immediately we start the analysis. Why? All these bhagam bhagi is because in minimum time we should get the maximum elements. Okay, so ये पूरा 8 दिन तक पूरी ये साइकिल चलती थी. हमारे गाइड जो थे प्रोफेसर गर्ग, वो मजे में बोलते थे कि सैंपल आते हैं तो यू पीपल शुड कुत्ते की नींद सोनी है, और अदरवाइज यू पीपल कैन रिलैक्स. ओके, जो मिनटों का होता है दैट वी हैव डन देयर इन द BRC, घंटों का होता है दैट वी विल भागम भागी करके नागपुर में करते हैं, और जो डेज और इयर्स में जिनकी हाफ लाइफ रहते हैं दैट वी आर रिलैक्स, वी कैन इन दिस वन. ओके, वी कैन इन एनालाइज आराम से. देन फ्रॉम गामा NA है इन वाइवो. This from gamma analysis, neutron activation analysis is useful for remote analysis of extraterrestrial bodies on and online analysis in industry. Okay, in vivo, a living patient. Okay, then as far as the applications are concerned, this neutron activation analysis have the multiple application in almost all the field. Major is which I have chosen is the environmental samples, but also it is the main characteristic of this one. It is the multi-elemental, non-destructive, highly sensitive, accurate and precise. Okay. As far as the multi-elemental analysis, I have told you that I have analyzed in 1 milligram of the samples 40 to 45 elements, and that to up to ppm parts per million and this nanogram per gram level. Okay, and that's why the paper was published in the very reputed journal of Science of Total Environment, Environmental Pollution, Analytical Chem Acta, Journal of Radioanalytical Nuclear Chemistry, and all that. All the international journals of high repute at that time, 35 years old. Okay, so this is the multi-elemental techniques, that is the non-destructive, at the same time it is accurate, precise, and it is the highly sensitive. As far as the application are concerned, it has the application almost all the field. बायोलॉजी में है, जियोलॉजी में है, आर्कियोलॉजी में है, फॉरेंसिक में है, इंडस्ट्रीज में है एंड एनवायरमेंट में तो है ही है. देन कम टू द दिस वन, NA नॉन डिस्ट्रक्टिव है, ये तो मैंने आपको बताया. Absolute comparator and K0 method, these are the different methods. Okay, we'll due to time constraint it is not possible to go into the details of this one. Then जनरली इसमें न्यूट्रॉन एक्टिवेशन इरेडिएशन होता है. इरेडिएशन के बाद साइक्लिक INA इंस्ट्रूमेंटल न्यूट्रॉन एक्टिवेशन एनालिसिस एंड रेडियोकेमिकल न्यूट्रॉन एक्टिवेशन एनालिसिस. देन काउंटिंग इज देयर, डाटा प्रोसेसिंग इज देयर, रिजल्ट्स आर देयर एंड फाइनली द conclusions are there. Now major contribution of NA opened up the field of trace element and their importance. Lead to recognition of several biological essential trace elements, provided the multi-elemental analytical methods of great use in biological and environmental studies, provided the valuable method for the certification of reference material of different matrices. Just I have told you in detail. NA has helped to establish the importance of trace element composition to determine the common and non-common origin of evidence specimen in forensic and archaeological studies. Greatly insisted in the analysis of lunar rocks and composition of meteorites. Okay, so here I am very happy to inform you that my Professor Garg, okay, he has analyzed these lunar samples and meteorite samples at Kentucky University, USA in 1975, and from there he got the idea of this neutron activation analysis technique. Then he developed the lab here in the Nagpur University, and we are fortunate that we have done in this case. Now, nowadays, few people are working because the nuclear facility and all that one are there, but at the same time, it is where the nuclear facilities are concerned, this is widely used technique. Greatly assisted in the development of semiconductor studies. Okay, interferences are there. NAA, a nuclear analytical technique, has no chemical interferences. However, nuclear interferences are possible. Okay, वो कौन से है? Formation of the same radioactive from the reactor. Okay, for example, in the determination of sodium in biological samples via N-gamma reaction, prompt nuclide is also formed by magnesium and this one. एक के साथ में बाकी दो reactions भी nuclear reactions will occur. Okay. Similarly, in the determination of aluminium bauxites in bauxites, okay, aluminium 27 N-gamma reaction से यदि prepare करना है तो aluminium 28 मिलेगा. Prompt nuclide is also formed by this one SI 28 NP reaction से aluminium 28 मिलेगा. Okay, इस case में what we are doing is that these elements have the different energies also. तो एक एनर्जीज पे एक इसका मेजर किए तो दूसरा वाला जो इंटरफेरेंस नहीं है वहां दूसरा का एलिमेंटल कंसंट्रेशंस वी आर एनालाइजिंग. दिस मे बी एलिमिनेटेड बाय कटिंग ऑफ हाई एनर्जी न्यूट्रॉन्स एंड यूजिंग थर्मल न्यूट्रॉन्स ओनली और अप्लाइंग करेक्शंस. देन spectral interferences due to similar energy gamma rays from other radionuclides are there in the determination of iron. ओके, इसकी दो अलग अलग एनर्जी होती है. एक एनर्जी पे यदि तुम्हारा इंटरफेरेंस है तो वी आर यूजिंग द सेकंड वन. ओके, interference may be eliminated by counting this one. Okay, similarly in the determination of selenium, okay, interference due to this mercury may be eliminated by counting the another energy or another photopeak. Then this is how the limits of detection in parts per billion, assuming 100 milligram of the sample. Okay, then sensitivity for different elements. Okay, 19 elements are known is designed, right? The elements are given, sensitivity is given, right? Now this is how we get our spectral data. Okay, in x-axis there is the energy, in y-axis we have the counts. Okay, and these are the peaks depicted to different element. Okay, depending on their energy, this figure shows a gamma ray reference spectrum obtained with 3200 analyzing channel. Okay, these are the experimental high resolution gamma ray spectrometry high purity germanium detector. Okay, long back, 35 years back. Okay, in that IIA Vienna project, we have procured this element. That project will be of 10 lakh at that time. You can consider, imagine, right? And this high purity germanium detector हमने वहां से जर्मनी से प्रोक्योर किया था, right? and with the help of this one, ये जो है बीच this one that will require the 30 liters of liquid nitrogen. The temperature is -197 of liquid nitrogen. Okay, उसका जो crystals है that was working at that temperature. So we have to put 30 liters of this liquid nitrogen daily in order to get working of this high purity germanium detector. And that was the sophisticated instrument. After BRC, we people only have this high purity germanium detector, okay, 35 years back. Now, advantages of NA. Irreversible applicability for major, minor and trace element analysis in a wide range of matrices for up to 60 elements, viral absence of any blank or chemical interferences, high specificity and low detection limits for many elements, non-destructive and multi-elemental characters, radiochemical NA through destructive provides interference-free. Determination in low detection limits and requirements of only a few amount of sample for analysis. These are all the major advantages as far as the NA is concerned. Now, applications. Okay, in short, I will give the applications. This chromium content of a ruby. The chromium 50 natural core chromium is converted to chromium 51, half-life at 27.7 days by N-gamma reaction. By irradiating with slow neutrons under identical conditions, a chromium bearing ruby with series of Al2O3 and Cr2O3 mixture of varying but known Cr content, it was found that the rubies have 0.1 to 0.4% chromium. The precision and the fact that the precious ruby remain undamaged at the end of the analysis highlight the value of this method of analysis. Okay, I have told you that as far as the applications are concerned, it is the non-destructive. Okay, ruby का यदि एलिमेंटल कंटेंट निकालना है, क्रोमियम कंटेंट निकालना है, तो उसको तोड़ के उसकी ये करके अपन तो नहीं कर सकते ना. So for that one, this technique will be very much helpful. It is the non-destructive. We can irradiate it and then we can determine the elemental concentrations in the ruby contents or the chromium contents in the ruby. Next is manganese contents of the tea leaves. Manganese 56 with a half-life of 2.5 hours is obtained by irradiation of manganese 55 by N-gamma reaction. Neutron irradiation of known weight of dry tea leaves, or better it's calcified along with series of samples of known Mn contents reveal that tea leaves contain around 0.13% of Mn, about half of which passes into the brew, that is the extract, and rest go to the waste. Okay, ये जो tea leaves का जो manganese contents है, ये यदि निकालना है, so neutron activation analysis is the better option for that one. Then archaeological specimens. NA has helped in determining the precious composition of some ancient coins non-destructively, and the result have shown light on their historical and geographical origin. Similarly, the analysis of colored poetry shades of archaeological discoveries go to be established the possible age, geographic proximity, and available mineral and trend routes in vogue. Besides throwing light on the development of ceramics in that region and that of epoch, all these achieved without destroying the valuable specimens. Okay, जो पुराने दस्तावेज है, जो पुराने specimens है, okay, उसको with the बिना तोड़े फोड़े, right, we will keep it as it is, and we are enabled to predict that which elemental contents it has and which time it was there, right? What is the time, probable time of that particular specimen? Okay, as far as the archaeological precious samples are there, precious specimens are there. Okay, this neutron activation analysis has much help at that time. Now, arsenic in hair, slow arsenic poisoning. The monoisotope, that is the arsenic 76, is obtained by neutron N-gamma reaction from arsenic 75. Any arsenic containing in human body is known to accumulate in roots of hair and move along the length of the hair as it grows. The normal rate growth of hair in most people being 0.35 mm per day. ये जो है नॉर्मल रेंज है हर एक इंसान में. ओके, जैसे जैसे आपका यदि आर्सेनिक एक्यूमुलेट होता है, ओके, तो मोस्ट ऑफ द पीपल इट बिकम्स 0.35 mm per day. One can analyze the hair by NaA to arrive at the AS amount. तुम्हारे हेयर में कितना आर्सेनिक का कंटेंट है ये यदि एनालाइज करना है तो यू हैव टू यूज दिस NaA, and this is of very much important for this one. This analysis would be very useful in the case of if the person dies of the arsenic poisoning. आर्सेनिक पॉइजन से यदि किसी की डेथ होती है तो उसका हेयर एनालिसिस किया जाता है और उसके हेयर में कितना डिपॉजिट हुआ, डिपेंडिंग ऑन दैट वन वी आर एबल टू प्रेडिक्ट द cause of that death and all that one. By cutting the hair into small pieces, the distribution of AS as a function of length might provide the time when AS was initially injected by the person, if it is the poisoning case. Okay, while normal hair would have 0.8 microgram per gram. Any value in excess of this one is considered to be dangerous. It is reported that 10.4 microgram per gram of arsenic was found in the hair of Emperor Napoleon Bonaparte, who died in May 1821. नेपोलियन बोनापार्ट के हेयर जब एनालिसिस किए गए तब पता चला कि उसके हेयर में the cause of this one is due to the arsenic poisoning, and that was 10.4 microgram per gram, whereas the normal value is 0.8 microgram per gram. Okay, next application is pre and post 1850 paintings. An interesting and valuable application of NaA is that it permits distinguishing between painting pre-1850 era from forged and fake substituted of later date. This has become possible because the paints available in 1850 period differed in the microgram composition at the ppm level in respect of several trace elements from the paints of more recent origin. All that is necessary, that is the trace amount of paint is may be picked up on a needle point. For NaA, the precious painting remained undamaged. Okay, as far as the Maharashtrian peoples are concerned, here in Ajanta Ellora caves, okay, have you visited that Ajanta Ellora caves? Then caves number 2, 8 and 20. Okay, very important, very good paintings are there, but the green color they have used there. Okay, though the science is too developed, but we didn't prepare such type of shades. That of course at that time they have prepared from the plant extract. Okay, so which one is the original? In order to know which one is the original and which one is the fake, okay, we cannot replace that original poetry or original paints with that of the fake one, right? We cannot substitute it. Okay, and that's why what they are doing is that only नीडल के इस पे पॉइंट पे जितना सैंपल लगता है उतना ही सैंपल लेके न्यूट्रॉन एक्टिवेशन एनालिसिस से एनालाइज करके यू आर एबल टू फाइंड आउट which one is the original and which one is the fake. Okay, so for that one this technique is very much important. Now advantages है तो disadvantages भी है. Requires nuclear reactors which makes it less accessible and cost effective. एक तो स्टैंडर्ड्स है तो इसके कारण वो कॉस्टली होते हैं और न्यूक्लियर रिएक्टर हर जगह नहीं होती. ओके, लॉन्ग टर्म अराउंड टाइम स्पेशली फॉर लॉन्ग लिव्ड रेडियोन्यूक्लियर्स. पेशेंस तो रखने पड़ते हैं, राइट? No information on chemical speciation as Na provides total elemental concentrations. Some environmental elements, important elements such as lead, thallium, nickel, low Z elements, that is SCN, cannot be determined. It cannot be automated or only partial automation possible after irradiation. So this is all about the neutron activation analysis. Okay, it may be water sample, it may be air sample, it may be what is called as the particulate matters. Okay, whatever the environmental samples are there, that we are able to analyze with the help of this neutron activation analysis, and that up to level of nanogram per gram, or in the up to 40 to 40, only in 1 to 2 gram or 2 milligram of the samples, we are able to find out 40 to 60 elements in average, okay, elemental concentration, and that too up to ppm per microgram per gram level, or even up to nanogram per gram level, okay, depending on their half-life, depending on their energy, we are able to find out the elemental concentrations, okay. So somehow it is the sophisticated technique, or at the same time it is the accurate, precise, multi-elemental specific techniques, and fast also, okay. We are able to find out the in 2 gram of the sample with 40 to 60 elements within shortest period of time, okay. Now, next technique that we are using is the isotope dilution analysis, okay. So the name itself suggests that isotope is diluted, radioisotope is diluted. Initial period में मैंने आपको बताया है कि what this radioactive isotopes and all are there. So they are diluted, and then after dilution, the analysis is carried out. In this method, a known weight W of the material of known specific activity S is added to the system. The radioactive material is diluted with inactive material having weight W1. This results in the decrease of the specific activity of the resultant sample. The extent of decrease depends on the relative amounts of the element in the radioactive material and the unknown sample, which one is the stable. If a part of the material is separated, for example, by precipitation, and its specific activity S1 is determined, then W1 can be calculated based on the conservation of total activity as follows. That's W1 is equal to W into S upon S1 minus 1. The advantage of this method is that the unknown sample need to be chemically pure. Quantitative separation is also not necessary. The quantity of iodine in the sample is determined by IDA using iodine 131 tracer. Iodine is separated by AGI before this precipitation titration. Okay, iodine is separated by AGI before and after dilution. Specific activities of AGI precipitates are compared to calculate the amount of iodine originally present in the sample. Let the quantity of iodine in 0.1 ml of tracer solution be W1 grams, and the total radioactivity A1 counts per minute, that is counts per minute, then specific activity S1 of the iodine in the tracer solution is given by S1 is equal to A1 upon W1. Okay, so A1 is equal to S1 into W1. When an aliquot of the unknown sample having W grams of inactive iodine is mixed, 1 ml of this tracer solution, there is no change in the total activity. It remains as A1. However, the specific activity of the iodine in solution decreases, okay, to S2 as the weight of iodine in the solution is increased. So S2 is given by S2 is equal to counts per meter per gram, that is equal to A1 upon W1 plus W. So A1 is equal to S2 into W1 plus W. Okay. And from equation 2 and 4, we get S1 W1 is equal to S2 into W1 plus W2. Hence, the weight of the iodine in the unknown sample W is given by W is equal to W1 into S1 by S2 minus 1. This, of course, the calculations and all this part will be very easy if we perform the actual experiment. Okay, ऐसे इसमें से नहीं पता चलेगा, लेकिन if we perform, these are the simplest way which I can tell you. Okay, so this is how we will able to find out the amount of elemental concentration in the given sample by isotope dilution analysis. IDA has been effectively used in organic and biomedical investigations where complete separation are often difficult to perform. Okay, IDA, that is the isotope dilution analysis, is being applied in situations where quantitative isolation of an element is either difficult or it is impossible. Okay, जहाँ पे एग्जैक्ट आपको काउंट करना है, ओके, और वो जो एलिमेंट मतलब पॉसिबल नहीं है, राइट, सो वहां पे आईडीए काम करता है. देन कंप्लीट सेपरेशन इज टाइम कंज्यूमिंग. Then amount of analyte is very small. It is not necessary to take the entire sample for analysis. Okay, these are the applied or in this situation, radioisotopes analysis will help you. Okay, this will be clarified from some examples I will put here. Okay, so some numericals are there. From that numericals you will get the little bit idea regarding this one. For example, 1 ml of blood from patient is withdrawn. पेशेंट में कितना ब्लड है ये अपने को पूरा, मतलब एक पेशेंट है, डॉक्टर्स को पता चलना है उसके बॉडी में कितना ब्लड है, तो वो पूरा का पूरा ब्लड लेके तुम मेजर नहीं कर सकता. सो इन दैट केस व्हाट ही इज डूइंग इज दैट 1 ml of blood from the patient is withdrawn and labeled with sodium 24 NaCl. ओके, हाफ लाइफ है 14.9, एक्टिविटी है उसकी 20,000 count per meter. This injected intravenously into the patient. ये उनके intravenously उसको inject किया जाता है. After 15 minutes, right, 1 ml of blood is withdrawn from patient for measuring the activity. It gives a specific activity of 4 CPM per ml. The observed decrease is due to the dilution of this sodium activity in the entire volume of the blood. Okay, पहले तो 1 ml उनको इंजेक्ट किया, वो पूरे बॉडी में सर्कुलेट हुआ, ओके, और फिर डाइल्यूट करने के बाद देन हाउ टेकन इट, ओके, एंड मेजर. सो it gives a specific activity of 4 CPM per ml. Okay, by activity balance, volume of the blood of the patient is calculated. That 20,000 initially थी, okay, 1 ml withdraw किया, so आपको मिला 4 into V plus 1, and that's why V is equal to 499 ml, that is the 5 ml, and the problem of the doctor is solved. So calculations are there. Specific activity radioisotope S1 A1 by V. So you get this one, okay, 20,000 into A1 by 1, that is do A1 is equal to 20,000 into 1. Specific activity of sample plus isotope, you get this one, and finally V1, that is 499 ml. That was the blood pressure present in that patient. Okay. Next problem is 0.6 centimeter cube solution containing 7.5 microgram per meter cube of the Fe was injected in the bloodstream of the horse. After equilibration, 1 centimeter cube of the blood was taken out and it gives 13,239 counts in 3 minutes. Calculate the blood volume in the body of the horse. It's again very difficult, right? So here also the activity balance of isotope dilution analysis will help you. 7.5 microgram per kilogram per centimeter cube, that is equal to 7.5 into 10 to the power minus 6. The calculations are there. You get 27.75 into 104 CPS. Okay, total activity was 0.6 into 27 points this one. We get 166.5 into 104 TPS. Activity of blood taken out is given as 73.54 CPS. Let the volume of blood in the body of the horse is be X centimeter cube. As the amount of solution added to the horse body is insignificant compared to the large blood volume, it is not necessary to use equation. Instead, we can assume the consistency of total activity because of the long half-life of radiotracers. Okay, the half-life is 44.5 days. Okay, and if we calculate the amount, you get horse body contains 22.6 decimeter cube of the blood. In this way, with the help of this IDA, this isotope dilution analysis, we are able to calculate the quantitative identification of the trace elements which are not possible otherwise. Okay, with this, I think I will like to stop here. But before that, the n number of environmental samples. I have given the madam the topic nuclear analytical techniques, neutron activation analysis, and evaluation for the analysis of the environmental studies. Initially, I have told you that environmental analysis is the burning topic nowadays, right? So you have to analyze these samples, air samples, water samples, particulate samples, okay, by different methods. But along with that, these are the sophisticated methods, that is the neutron activation analysis and that of the isotope dilution analysis, okay. So with that, we are able to, that all the 5 criteria for the which analytical chemists are always in search of, that is the, it is very accurate, it is very precise, okay, it is fast, it is universally applicable. So these both the techniques, neutron activation analysis and isotope dilution analysis, will fulfill all the criteria, and we are able to find out the analyze the environmental samples as far as possible into ppm part per million and nano per gram level. Okay, with this one, this is all from my side. Questions, please. Thank you for your patience listening. Yes, madam.
Yes, ma'am. Thank you so much, ma'am.
Yeah.
Thank you.
Participants.
Thank you, madam. Madam, are you talking about Professor Amarnath Garg?
Yeah,
Garg?
yes, sir. Yes,
Okay.
sir. Yes, sir. I'm really lucky. I'm the.
Yes, madam. I am also lucky to be his students in masters.
Where?
At IIT Roorkee.
Oh, yes. Sir has left from here in 1997 and he has appointed as a professor in their
University of Roorkee. Yeah.
university, Amity University. Sorry,
Oh.
This IIT Roorkee.
Yeah,
Yes.
later it becomes IIT Roorkee in 2011.
Yeah. He's retired there from 2006.
Yeah.
Yes.
Now he's in, I think he's in
Ghaziabad.
Bombay or Ghaziabad with sisters many times on Facebook. I have seen his
अच्छा
pics.
नहीं, उनके दोनों बेटियां इधर है, एक भोपाल में, एक बम्बई में है. Sir has worked at that Amity University for some time. I mean for up to 2000 recently 2019 तक वो वहाँ पे थे Amity University में. Now after that knee operation and all that one, he has left.
Yes.
Okay. Your good name, please, sir?
Madam Sudhanshu, Dr. Sudhanshu Pratap Singh.
Okay.
Madam, I have a question here.
Yeah.
In case of elemental analysis in NIA, suppose if different elements, they have different neutron cross section values.
Yeah.
Like both carbon as well as cadmium is there. So if you are using the same one common fixed flux of the neutron, are you not going to miss any of the element because of the low cross section?
Sir, I have told in the applications part, disadvantage of this one, that low detection limits will not be there. Okay, but in that case, some interferences are there. Okay, if the same energies are there, if the same half-lives are there, okay, in that case, we are using the next one, that is the other energies. For example, iron के case में दो अलग अलग energies है, एक इसमें यदि spectral interferences है, तो naturally we will measure the peaks of the next energy. Half-life will remain same, right? So we are using the next one. Yes. Hello.
Yes, anybody?
Yes, ma'am. I have one question.
Yeah.
I think for the such type of work, radioactive type, we have to take the for the lab development, we have to take the permission from government, ma'am, something like that.
Yeah. Yes, sir. Our
so how the things.
That's why I told you that my guide, Professor Garg, had worked there in the Kentucky University, USA. There he analyzed the lunar samples, okay, meteoroid samples. There he got the idea of this NAA. Then he worked here in the BRC, right? And he was in contact with the most of the peoples in Bhabatom Research Center. So with the help of that one, he applied for the project, right? So n number of projects on this nuclear chemistry he has completed, and then we have the collaboration Okay, long before, मतलब साल पहले, our group is very vibrant. We have Professor Garg has only 40 students, but the 40 students आज के 1000 मतलब 100 students से equivalent थे. Okay, so they have the n number of projects, बड़े बड़े projects उनके पास थे. So and they have the good collaboration with that of the BRC people. So we people, मतलब as a research student, we have the permission to stay there in the BRC for 2 months and all that one. All the things they are managing. I mean, BRC people at training school hostel, they used to kept our permissions. We myself also go into the nuclear reactor and pick up my samples by my own hand and take it out. Some transportation and all that one that people are taking. Okay, then we are analyzing our samples in the radioanalytical nuclear chemistry laboratory of BRC itself. Okay, as far as the short radionuclides are concerned. But as I have told you that in the other this one for medium half-life or for the long half-life, we have to sir has developed here. We have the project from International Atomic Energy Agency, IAEA now. Under that project, we have procured that high purity germanium detector of 5 lakh at that time, 35 years back. Okay, and on that instrument, we are analyzing the samples. So very good collaboration with that of BRC and the Nagpur University. We also have the isotope generators, that is the isotopic source. The americium beryllium source is there. Then we have the gamma radiolysis, third field is also there. That cobalt 60 source also still with us. And that facility of radiation chemistry is continuing here in the nuclear chemistry laboratory of the Nagpur University. Yes.
तो मैम 2-3 साल, हमको लगता है कि 2-3 साल लग जाता होगा गवर्नमेंट से परमिशन लेने में कि आप इस तरह का काम देन यू कैन स्टार्ट.
दिस सर, आपके कैसे टर्म्स है, आप मतलब कैसा काम है आपका, अर्लियर आपका बैकग्राउंड कैसा है, राइट?
एग्जैक्टली
उसके साथ ना इट्स है ना, एक बार तुम्हारा इसमें आ गए तो फिर यू कैन कंटिन्यू इट. सर का वो वाला बैकग्राउंड था. ही हैज कंप्लीटेड हिज PhD फ्रॉम कानपुर IIT और उसके बाद फिर वो पोस्ट डॉक के लिए केंटकी यूनिवर्सिटी में गए. वहां पे उन्होंने न्यूट्रॉन एक्टिवेशन एनालिसिस से एनालाइज की. सो विद ऑल दिस बैकग्राउंड ही गॉट द एडमिशन, ही गॉट द परमिशन फ्रॉम BRC.
राइट
है ना. और उसके कारण हम लोग सब मतलब वी आर द ऑल द बेनिफिशियरीज. I am the student of Department of Chemistry. I am the professor in the Department of Chemistry. I am very lucky.
Yeah, ma'am. Otherwise, for new candidate, it's very hard to get the permission and all the formalities.
Yeah. Even the working is also लोगों के दिल में थोड़ा सा ये लगा हुआ है कि न्यूक्लियर केमिस्ट्री में काम करना है. मुझे भी काफी हर्डल्स किए थे, काफी लोगों ने डराया था ऐसा होगा वैसा होगा, कुछ नहीं हुआ सर. यू हैव टू टेक द प्रॉपर प्रिकॉशंस, दैट TLD बैच वगैरह सब पहन के तुम जाओ वहां पे न्यूक्लियर रिएक्टर्स में से अपने. अदरवाइज तो पीपल विल नॉट वर्क इन द BRC. ऐसा ही रहता तो फिर हवा एटॉमिक सेंटर में लोग काम ही नहीं करते ना सर.
नहीं कर पाते,
है ना. तुम यदि प्रॉपर प्रिकॉशंस लेके काम करोगे तो फिर इट्स पॉसिबल. अदरवाइज नहीं होता है बोले तो फिर कुछ भी नहीं होगा.
लेकिन मुझे लगता है मैम एवरीडे चेक करते होंगे. जैसे आप लैब में वर्क किए फिर वहां से निकले तो आपकी बॉडी पूरी चेक होती होगी.
नहीं सर, उसमें एक छोटा सा जैसे बैच रहता है सर, अपना जैसे आई कार्ड रहता है ना वैसा उसको TLD बोलते हैं, थर्मल लुमिनेसेंस डिटेक्टर. ओके, और तुम कितने रेडियो एक्टिविटी को एक्सपोज हो गए तो उसका एक परमिसिबल डोज रहता है. तो वो जो है TLD, वो हर महीने में हम लोग जो न्यूक्लियर केमिस्ट्री लेबोरेटरी में काम करते थे हर एक के नाम का TLD बैच आता था वो BRC से. एंड देन हर 3 महीने के बाद और TLD बैच मेजर होने के लिए BRC जाता था. और वहां से फिर तुम्हारी एक परमिसिबल लिमिट रहती है कि यहाँ तक तुम कर सकते हो, इसके आगे यदि तुम एक्सपोज हो गए तो दे विल आस्क अस टू स्टॉप द वर्क.
राइट
तक हमको रुकना पड़ता था. ओके, ऑफ कोर्स वैसी नौबत आई नहीं किसी के इसमें, लेकिन वी आर टेकिंग द प्रॉपर प्रिकॉशंस. ओके, और देन आफ्टर 6 months अपनी तो बॉडी चलती रहती है, अपना ब्लड बनता रहता है, बॉडी साइकिल इज गोइंग ऑन. ओके, तो फिर 6 महीने के बाद अगेन वी कैन कंटिन्यू. तो वो TLD बैच जो है, तो अनलेस एंड अनटिल यू वेयर दैट TLD बैच यू कैन नॉट एंटर इनटू द रेडियो केमिस्ट्री लेबोरेटरी, नॉट एट BRC, नॉट एट नागपुर यूनिवर्सिटी न्यूक्लियर केमिस्ट्री लेबोरेटरी.
Right, ma'am. Very informative lecture, ma'am. Very informative. Thank you.
Thank you, sir. Thank you very much.
Thank you, ma'am.
Any question?
Yes, any question?
Yes, ma'am. I wanted to ask one question, ma'am.
Yes.
Yes, ma'am. Ma'am, if we're considering this analysis in recent years, so what is an approximate cost for neutron activity analysis? Approximate cost for single sample analysis.
Yeah. Now that what is called as collaboration, and it is possible that permission should be there. Cost wise, of course, it is the cost effective. Okay, you should have either, if you want to analyze the same here in the either you have to set up the laboratory, or nowadays it is not, no one is working in this nuclear. Very sorry to say that even in the nuclear this chemistry department of Nagpur University, no one is going to study with or working in this neutron activation analysis. Okay, in Pune also almost everything is stopped. Okay, government is not giving the permission for the new appointments and all that one, whatever the reasons may be there. Okay, so unless and until BRC people, they are not giving you the sample analysis, right? So either you have to develop the labs and all that one, and or you have to analyze the samples, get the permission, and work there in that their laboratory. Depending on your terms and all connections, you can analyze it. न्यूक्लियर रिएक्टर तो आप हर जगह नहीं कर सकते हो ना, उनकी ही परमिशन लेनी पड़ेगी आपको, तो वहां जाके आप एनालिसिस कर सकते हो.
Okay. Thank you, ma'am.
Welcome.
Is there any question now? Okay, I think, madam, there are no more questions.
Okay.
Thank you so much, ma'am. We really feel proud of you.
Yeah, thank you very much.
As you are the first lady who are working in this field from Vidarbha. So
yeah, I'm proud to be. And that too up to 89 to 95. Even BRC people also appreciate me a lot. Because at that time, nowadays too common. But at that time in 89, when I joined there, okay, so I was the only lady working there in the radiochemistry division and taking the samples from nuclear reactors and all that, analyzing their same setup. Okay, so I'm lucky that way. And I got the chance to work in that IAEA Vienna. I got the fellowship from International Atomic Energy Agency, Vienna fellowship. And that was the headquarters of nuclear chemistry, right? So under that project, I have used work as a co-investigator. And that's why I got the number of publications and all that one. And best on that one, I am selected as a professor in Nagpur University, though after a long gap, but for 13, 14 years, I have served there. Thank you very much.
Very inspiring, madam. Thank you so much.
Okay, thank you. Thank you very much.
Yes, ma'am. Formal vote of thanks.
Participants for patience listening.
Thank you, madam. I request Dr. Hegde.
Myself, Dr. Ganesh Sridhar Hegde from, I'm an associate professor in MM Arts and Science College, Sirsi in Karnataka. I take this opportunity to present a vote of thanks the madam's presentation, which which was quite inspirational. Professor Mamta Lanjewar madam from RT Maharaj, Nagpur University. Her presentation on the nuclear analytical techniques like neutron activation analysis and isotope dilution techniques went quite nice. With the journey of our presentation went with the basics of nuclear science, nuclear reactions, and then with the neutron activation analysis and its types, and of course the story of her NA analysis in the bark and all. And of course with the application and interferences, and of course with the finally with the advantages of NAA and its applications in the various fields like Ruby analysis, and then manganese in tea leaves and so many archaeological specimens, etc. And also finally she went on with the isotope dilution techniques with several examples. Madam, it was truly inspirational, and also I feel you are quite fortunate with working with this very rare field of research.
Yeah.
So not all people will get this kind of opportunity.
Yeah. I'm lucky. That way I'm very lucky, sir.
Yeah, that's madam. So and on behalf of all the participants with the this refresher course of SGBAU Amravati University, MMTTC, I present a heartfelt vote of thanks to you for this wonderful presentation, madam. So we are all greatly benefited with this talk. And I also thank Kodape madam for the for this organizing all these things. He is the course coordinator, and also I thank Shri Ankit Thakur, the technical head, who is helping us in on a daily basis and arranging all these things. And I thank all the fellow participants in this refresher course for their active participation. Thank you one and all.
Thank you. Thank you very much.
Thank you so much, ma'am.
Thank you. Okay. चलो मिलते हैं.
Yes, ma'am.
Okay,
Thank you, ma'am.
Thank you.
Best
Thank you. Thank you,
wishes,
sir.
ma'am.
See you.
See you.
We'll start our next session on 2:30. Hello?
Okay, ma'am. Okay,
Yes,
ma'am.
ma'am.
Yes. Okay.
Okay, ma'am.
Hello.
Chemistry, SK Government College Kamali, Rewadi. Thankful to the organization of the course, MMTTC Sant Gadkari, to introduce today's third session resource person Dr. Vishal Banewar sir. Dr. Vishal Banewar sir is currently an associate professor in the Department of Chemistry at Institute of Science, Dr. Homi Bhabha State University, Mumbai. Sir completed his PhD from the university. He is recipient of merit certificate at SSC BS research paper in Royal Society of Chemistry, elsewhere and other reputed journals. Sir has completed major research project and another CSR project for empowerment of women about cyber security and digital financial inclusion. Sir also completed 3 minor UGC research projects under his supervision. One student has been awarded PhD and 5 other students are pursuing their PhD. Hold many professional responsibilities and linkages: Director of Skill Development Center, Director of IQAC, Coordinator of PM USA Homi Bhabha State University, Member of Management Council, Academic Council, State Level Quality Assurance Cell, Denaturant Committee, Government of Maharashtra, GPR Committee, Government of Maharashtra, Member of Board of Studies, polymer dots, organic synthesis, organic electronic devices. Sir, topic of today's talk is very interesting, that is changing chemistry education from traditional syllabus to sustainable development goals. This is only the brief introduction of Dr. Vishal Banewar sir. Without consuming much more time, on the behalf of MMTTC, Sant Gadge Baba Amravati University and all fellow participants of this refresher course, I welcome you sir to share your valuable research experience with us. Again, I welcome you, sir. Now over to you, sir.
Thank you, ma'am. Thank you for a brief introductions. And I hope I'm audible. I'm clearly audible to everyone.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, thank you very much. Thank you for prompt response.
Yes, sir. You are
So I would like to thank UGC MMTC Santa Gadge Baba Amravati University for giving me opportunity to share my view on a very important topic. So that is, we can say, a hot topic of today's era about the sustainable development goals. That how we can achieve these sustainable development goals. I think my voice is clearly audible to everyone, and I'm properly.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Yeah. Thank you. Thanks a lot. So this is what we are trying to understand: how the sustainable development goals can be introduced into the traditional syllabus of chemistry that we are teaching, keeping the burden of our traditional syllabus that we need to complete, because that is our main task. Obviously, someone will ask, like at the end of sessions or end of academic sessions, everyone asks to us how much percentage of syllabus you have completed for your academic year. And that is going to be reflected in your CR, that is going to be reflected in your APIs. And again, if some IQAC is taking feedback from the students, the same questions will be there. How much syllabus has been completed? And if we are not able to complete the syllabus, obviously there will be a bad, you can say, a bad marking for us being a teacher, right? So I try to do this today. I'm trying that we need to complete the syllabus, but at the same time, how the same things can be do so that we can achieve the sustainable development goals. Like what are the, or we can say how the traditional syllabus can be just teach in a way so that it could be look like it's a green chemistry. And that's my today's aim is there. So thanks to everyone for being attentive for this one, and thanks for kind introductions of me. What I try to do today, I hope that we will be as being and we are all teachers, and we know that this is after. I think that this is after lunch break. I hope that we had a good kinds of lunch, and many of us is always already enjoying rainy season. Here also in Mumbai, I am enjoying my rainy season. And in this one, we will try to have some kinds of interactive discussions regarding this, my view and your view, like whatever I'm sharing. So I hope that you will all will be very attentive and will be very responding in the what kinds of the things, what kinds of the some kinds of the games, some kind of the activities we are trying to do with in these today's sessions. So with this, I will like to start my format. What I suppose that chemistry education must now move from content completions to responsible scientific formation, right? So see, chemistry has always been one of the most powerful science in human history. Like it gives you societies, medicines, fertilizers, polymers, fuels, materials, disinfectants, batteries, dyes, semiconductors, and many life-saving technologies. But at the same science is also connected with the pollution, toxic exposure, plastic waste, industrial hazards, greenhouse gas emission, and obviously the irresponsible consumptions. But this does not mean chemistry is the problem, right? It means chemistry education must become more responsible. This is my word today is the aim is that we just wants to make the chemistry education more responsible rather than to make the more problematic. Now, AME session is not to reject traditional chemistry. That the same thing that I was initially I talked. Atomic structure, bonding, thermodynamics, kinetics, stereochemistry, organic reactions, coordination chemistry, electrochemistry, analytical chemistry. Obviously, they will always remain essential, right? But at the same times, but now the question is a little bit different. Are we teaching this topic only as examination content, or are we preparing students to use chemistry for a safer, cleaner, and more sustainable world? Now, what will be the aim of my today's talk? It's to just make all the traditional topics, or to just explain that how we can just the traditional topics can be just reframed into that particular in green chemistry, or you can say the more sustainable chemistry topic, and so that the chemistry could becomes the responsible, right? So with that, just I will like to share my screen. I hope everyone is able to see my screen.
Yes, sir. Yes, sir.
Yeah. So this is the view I'm going to try. I'm trying to share my view with yourself. We all the teachers. Changing chemistry education from traditional syllabus to get the sustainable development goals. Frankly, initially, let me make it very clear that this session is not about giving decorative lectures on SDGs, that's the Sustainable Development Goals, because already many institutions put SDG logos on posters, reports, and presentation. But the real academic challenge is a little bit deeper. what I thought about the session outcome, that once the session is over, so what will the participants or the teachers will come to know? Chemistry teacher should ask, how does STG thinking enter my lessons on thermodynamics? How does sustainability enter my organic chemistry practicals? How does analytical chemistry help students to understand water quality, food safety, and environmental monitoring? How can electrochemistry be connected with the batteries, hydrogens, corrosions, and energy storage? So, what I thought, the SDGs are framed as interconnected goals for global actions. Can I ask the participants just one questions? Which one chemistry topic do we teach that can connect with a real social or environmental problems? Because now you are all from the, like you can say, you are from all the like all over from the India, and you are belonging from different kinds of universities from all over India. So I just want to know, how many people think that they are teaching the topic that can be connected with real social or environmental problem in terms of the chemistry?
Analytical chemistry, I think, majorly deals with these
Pollution, topic name pollution.
Good. So we had the analytical chemistry, we had the topic name pollutions.
Yes, sir.
Spectroscopic chemistry, sir.
I think, sir, all the topics are eventually related to
Sustainable materials.
Sustainable materials, right? More?
Nanotechnology, sir.
Sir, pharmaceutical chemistry.
Pharmaceutical chemistry, nanotechnology.
So green chemistry.
So what I just expect at the end of these sessions, what are the topic you just tell me that you people have said that this will be correlate with the concern with the social, real social or the environmental problems that you are teaching to your students, either in a theory way or either in a practical way. So how do you involve SDG into that your teaching? So at the end of sessions, we will take a few examples, like we will take a few views from you, from your side, that being a teacher, how you involve SDG in your teaching while teaching these kinds of topic, which will be really related with this real social or the environmental problems. Okay, so at the end, like we had 1.5 hours for from right now. So at the end, we will take few views from your side where we can say that, sir, this is way how I'm going to teach my topic, but that includes the SDG, that I'm going to cover my sustainable development goal without disturbing my traditional syllabus. Okay. Okay. Now this is this is one of the things that I want to explain. One chemical discovery and two stories. Now let me have some more kinds of focus some more lights on this one. Take ammonia synthesis as an example, right? The production of ammonia made a large-scale fertilizer production possible and supported food production. Because you know that ammonia synthesis is one kind of, we can say it's a magic, or we can say it's a great chemistry discovery for chemistry people. So because obviously it helps us to large scale fertilizer production possible and supported for food production. But at the same time, fertilizers overuse is also associated with water pollution and ecological imbalance. I think many of you already will agree with this one, right? Take an example of plastics. Plastic made packaging, medicine, transport, electrical installations, and consumer goods cheaper and more accessible, right? But at the same time, plastic waste and microplastic have become major environmental concern, because that today is the most dangerous things for environment pollutions. Is, we always say, it's a plastic and microplastic. So it's a one chemical, like it's a one chemical, this story, but it is having a two stories. Take an example again, antibiotics. They change modern medicine, but misuse and overuse have contributed to antimicrobial resistance. And many of us is already facing this problem, the overdose of antibiotics, right? So point is not to condemn chemistry. Like it's not the antibiotic discovery of antibiotics is failed, or discovery of antibiotics is not a good thing. Yes, it's a great thing, but the point is to recognize that every chemical solution has a life cycle. A chemical product is not complete when it is synthesized, but it has consequences during production, use, disposable, degradation, and environmental exposure. And this is the starting of the sustainable chemistry education. And this is what I want, that when at the end of sessions, you will, like someone of you will explain that your topic is, you're completing your topic in terms of getting SDG. So how you are tackling this one, like how you are preparing your students, that everything which we discover, everything which we synthesize, explain, that as always having a two stories. Now we need to, being a chemistry students, we being a chemistry person, we need to balance between these two one, right? So most important things is that, and because that is one of my question was there, like in during our teaching, do we usually discuss both these stories, like the benefits and consequences? Like I think that many of us already has taught of like many topics from this one. That's the list I had given, right? So the list I have given, I think that most of us have stopped. Like being in chemistry, we always going to be teach. This is the basic topics. But during teaching these topics to our students, do we discuss these more the consequences, like more the sides of this discovery, that we are discussing about the synthesis ammonia, how the ammonia has been discussed, how Haber cycles helps us, but at the same time, do we discuss its another sides of this discovery, that we are having this, like we are having these consequences. This is how we need to achieve our SDG, to include all these things, so that the consequences has to be again taught to the students. My very first question is that, are we teaching chemistry for yesterday or tomorrow?
Tomorrow.
Tomorrow.
Correct.
Tomorrow.
See, the traditional questions are not wrong. As I already said, that we don't want to change the traditional syllabus, or we don't want to change the traditional way of teaching, because that is the best way for teaching. I thought so, right? Traditional question is not wrong, because chemistry student must know formulas, mechanisms, equation, calculation, right? Because since without conceptual clarity, sustainability becomes an empty talk. We cannot expect the sustainability without the conceptual, like without the concept clearing, without knowing the formula, without knowing the mechanisms, without knowing the equations and calculations from the students. So obviously it's a completely empty talk. But however, alone is an incomplete. Like only asking these traditional questions: what is formula? What is structure? What is the mechanism? What is the reaction? What is the yield? What is the calculations? I think these are the one of common questions that we generally ask to our students during even our lectures, and even in some exams also, right? What future chemist must ask: is the process is safer? Is the solvent hatch? hazardous? Is the feedstock is renewable? How much waste is generated? Can catalyst be reused? What happens after disposal? What is the environmental and social cost? So what I say, we are not moving from chemistry to environmental slogans. We are just moving from isolated chemistry to the responsible chemistry. Do we know that what is the limitations of traditional syllabus, like traditional syllabus centered model? Most of the chemistry teachers work sincerely, everyone has to accept this once. Like even all the kinds of subject teachers, every subject teacher has to ask. Chemistry teachers has a lot of work, and we already we work very sincerely. So problem is not a lack of efforts. We are not lack in case of effort for taking effort for teaching the chemistry in a proper way or basically in the sustainable way. But the problem is often academic design within which we are expected to work. And this is the same thing that I talked very initially. Always the syllabus centered model often what ask completion, like always ask how you completed the portion. This is the same questions everyone we are facing every day, like everywhere in every sessions and in every colleges. We being in chemistry teachers, we always face the same questions. How you complete the portion, right? But in many institutions, students complete the experiments by following some instruction in journals. We know it. They know when the color changes in titrations, where to write observations and how to calculate the results. Students are very, very smart nowadays, but they may not know why the taste matters, what decision depends on it, what error may affect the results, or what waste was generated during the process. Right? So we taught in theory classes Lee-Chatter's principle, Nernst equation, Arrhenius equation, polymerizations, chromatography, and other special topics. But I think that the student does not know the connect of these topics with the industrial productions, energy efficiency, clean water, pharmaceutical batteries, battery technology, climate actions, or waste reductions. So basically what is happening, a traditional syllabus provides the skeleton, but the sustainability gives its living relevance. Right? May I ask my all colleagues, do our students remember chemistry as a set of chapter or as a way of understanding the world? How many of us think about this? The chemistry, like a students always remember, like student always thinks it's a set of chapters or it's a way of understanding the world. I think anyone can express its his view.
Yes, sir. Most of us also remember it as a set of chapter, but some are there, some students are there, some teachers are there. They take it as a way of life, sir.
Obvious. So this is what we want to just change. Means we don't want to change that it's a set of chapter. Like looking towards the chemistry, like a view towards looking towards chemistry is just little bit need to be a little bit different. So instead of looking it like we need to understand, we need to explain our students that it's not just a set of chapter, but it's a problem. Like chemistry is a problem, like solving. life solving. So you can solve any kinds of problems of life through the chemistry only. So if we are able to do that, that's what the SDG is there. So SDG is not to go just on a green chemistry slogans from traditional chemistry syllabus to the green chemistry slogans, but it is to attain the SDG through this kinds of the little points. Like it's not, we need to explain our students that it's not a set of chapters. Chemistry is not only a set of chapters. It is not a 4 chapters of organic, 4 chapters of physical, analytical, but basically it's a life solving. Chemistry is a life solving tools, and that you need to understand, right? So for that, we required some necessary shift in academic. Like we look to go from curriculum. So this is my view. Now I just want your view around this ones. What syllabus answers, what topic are to be taught? Right? But there should be a distinct difference between syllabus and a curriculum. Now I will give you some examples, right? See, a syllabus may mention polymers, but a curriculum asks whether students should study only addition and condensation polymers, or whether they should also examine plastic waste, recycling, biodegradable polymers, microplastics, packaging materials, and circular economy. Right? Syllabus may mention electrochemistry, but the curriculum asks whether students should have solved the problems on electrode potential, whether they should also connect electrochemistry with batteries, fuel cells, corrosions, prevention, electrolyzers, and green hydrogens. Syllabus may mention analytical chemistry, but a curriculum asks whether students should only perform titrations or whether they should understand evidence, accuracy, precision, detection limit, water quality, food adulterations, and public health. So, therefore, changing chemistry education does not mean merely adding a new units. It means changing the academic imaginations behind existing units. The deeper movement is from topic listening to purpose-driven learning. So we want to become more responsible rather than to remain isolated. So what basically we want from chemistry, like what is basically means by chemistry and SDG, that is sustainable goal. So basically, see, SDGs are often shown as on colorful boxes. So in chemistry education, they must be treated as a real academic entry point for SDG. Right? So we know that clean water requires analytical chemistry, adsorption, membrane chemistry, disinfection chemistry, material science. If it's a question of good health, so that requires a medicinal chemistry, pharmaceutical analysis, biochemistry, toxicology, and quality control. Like affordable and clean energy requires electrochemistry, catalysis, solar materials, hydrogen chemistry, battery materials, energy storage. Responsible consumption and production requires green chemistry, cleaner synthesis, waste minimization, safer solvents, and circular economy. Right? Climate action requires carbon chemistry, atmospheric chemistry, carbon capture, renewable fuels, process efficiency. Zero hungers connects with fertilizers, soil chemistry, pesticides, nutrient cycles, food prevention. Right? So chemistry is therefore not a narrow laboratory subject, but rather it's a fundamental science for a sustainable development. So being teaching as these kinds of topics, so we can correlate that these topics with with these ones to achieve that sustainable goals. That is making the chemistry as a responsible rather than to be isolated. out of these SDG goals related with the chemistry, can a participant teacher tells me that which are directly connected with your current research teaching or research area? See, these are all the SDGs, that is Sustainable Development Goals given by UNESCO, or basically it's given by some a global, you can say United Nations. These are the SDGs, and these SDGs we need to include in our syllabus, chemistry syllabus, keeping the traditional syllabus as it is, like traditional teaching the traditional teachings. But at the same times, we need to achieve these SDGs, because we chemists always going to be blamed most of the time that we are providing or we are polluting the environment. Now we has to give them the answer that we are not polluting the environment, but basically we are making the chemistry, or we are the life solving, right? So for that, what I want to know that how many of us can correlate our research works with all these SDGs, or even teaching work.
Yes, sir.
What I want to know ki,
yeah.
Which
Actually, sir, I am teaching my students, polymers. So I suggest to students, please carry the your bag, the class bag, or something like that. Don't use the polythene like that, sir.
Okay, so I think that you are doing your research in polymer
In
synthesis.
polymer area, sir. Biopolymers
Okay,
area.
biopolymers and biopolymers area,
So
right?
when I teach to student polymers about polymers, then I suggest to them avoid the polythene bags like that from the market. Use your homemade bag, that one class type like that, or cotton type bags, sir. I think it is going for the sustainable development goal a little bit.
Okay, so can you correlate your teaching, like what you are teaching or doing your research, with the points, with this point, any of these points, like any of the sustainable goals?
Because if you use the cotton bags and we avoid the polythenes, and this is going to green environment.
Yes, correct, sir.
Sir, as simple as carrying a water bottle. They should always carry their own water bottle instead of, buying a water bottle from the canteen or something like, So small things, in a habit will will fill up the gap. So,
Yes. That's a great initiative, ma'am. Just I want to just make it very much clear. This is the sustainable goals that the United Nations has given us, being an chemistry teachers, or United Nations has given to us being an chemistry teachers. So what I just wants to know that we need to think, being a teacher, being a researchers, that what kinds of teaching I am doing, what kinds of topic I am teaching to them, teaching to my students, what kind of research I am doing in my laboratory. So that kind of teaching, that kind of research is going to be correlate with which of this SDG, which is given by United Nations, right? So whether it comes in the zero hunger, whether it comes in life on land, whether it comes on life below water, whether it comes on climate action, whether it comes in the good health and well-being. So what I'm teaching, what I'm researching, so that points or that research, that output, that product is going to be correlate with which of these SDGs, right? So this is what just I want to this is just what I want to understand. Okay. So what I thought that chemistry education basically requires a system thinking. Now let me clear these things. So traditional chemistry often focus on reaction vessels, but the sustainable chemistry asks what happens before and what happens after the reaction vessel. Right? So basically what is happening? Where did the raw material come from? Was the fossil base or renewable? What energy was required? What is the solvent safe? Reuse, recycle, or degrade? Can it persist in soil or water? Can it enter the food chain? This is called the system thinking. So system thinking prevents narrow success. A reaction may have a high yield, right? But it produce the hazardous waste. Now, I will give you examples. Polymer may be strong and durable. That is our aim. Like when we are going to synthesize any polymer. So hello? Yeah. So polymer may be strong and durable because that is what when we are going to synthesize any polymer, either it will be a biopolymer or any kinds of chemical polymer. So our aim is that we always going to like find out what is the its durability and what will be the how it's strong, right? But at the same time, the durability may make it environmental persistent. Pesticide may protect crops, but may also affect soil organisms, water bodies, and non-target species, right? Chemistry students must therefore be trained to examine connections, not only isolated facts. A sustainable chemistry graduates should be able to see the whole chain, like material source, process, product, use, waste, and impact. So this is what we require to change a system. So our system is just what is system is always happening, always focus. It just focus on reaction vessels. What is happening in the reaction vessels? But the sustainable system or sustainable chemistry should focus on all these points. So to get that SDGs, what we had discussed in previous one, to get that one, we need to focus on this one. Right? So what is green chemistry? So it is basically the bridge between classical chemistry and the sustainability. Green chemistry is one of the most practical ways to bring sustainability into mainstream chemistry education. So what I want to say that it should not be treated as one isolated chapter to the end of the semester as in a green chemistry. So I think that in most of the universities or in most of our syllabus, so the green chemistry, we had the green chemistry chapter either somewhere in the end like SY or TY as in one chapter or two chapter. Right? I think most of us will agree with this one. It should become a lens through which the entire chemistry curriculum is reread. When teaching organic synthesis, discussion of atom economy, solvent choice, and reaction conditions. When teaching catalysis, discuss selectivity, energy, efficiency, and catalyst reuse. When teaching polymers, discuss degradation, recycling, and environmental persistence. When teaching analytical chemistry, discuss monitoring, detection limit, and public safety. When teaching industrial chemistry, discuss cleaner production and safer safety. So green chemistry will use us a scientifically valid way to connect chemistry with the sustainability without diluting the disciplinary depth. So basically, it should not be the one single chapter or it should not be the one or two points which is included in our syllabus, but it should be like green chemistry should be the way through which we are looking towards the chemistry, whole chemistry, like all sorts of chemistry topics, whether it will be organic chemistry, analytical chemistry, physical chemistry, inorganic chemistry, industrial chemistry. So every topic we need to see through the lens of this green chemistry. So green chemistry focus on designing chemical product and process. Like we should, while teaching every topic, so about waste, atom economy, hazardous substance, energy demand. So all these through all these lenses, we need to look toward the topic that we are teaching. right? So this is what I think. How many people say, all of us, like from us, how many will say green chemistry is not a pollution control after damage? How many all of of us will agree with this? And how many of us will agree that we are right now, still now, we are not teaching green chemistry as this statement? Like, see, what is my conventional approach is that if anyone has some different views with this one, please let me know. Let me know, right? So, what is my conventional approach? Make the product, generate waste, treat pollution, and then dispose waste, right? So this is my conventional approach for any kinds of synthesis, for any kinds of topics. So what is happening now, right? Many students think environmental chemistry means studying pollution after it has already occurred. Do everyone agree with this?
Certainly, sir.
Yes.
I just have a point to say, sir. As a chemist, we try to control the pollution, whereas we are creating a lot of pollution in the lab. So, what should be the solution for that? Like, as simple as doing a brumination.
So I think that when we will complete this, when we'll go through whole this interactive talk, so then we will come to know that how the same things will be. Like, as I already said, the addition of the another unit is not a solution. Like in our syllabus, adding the another unit and making the more and more burden to the chemistry teacher is not a solution. And that too, the just shifting from this one, like obviously, as I said, traditionally the student should know all these points. Like they should know the product generation waste and everything. They should know. Like synthesis of product, they should know. But what my aim is that just how to just restructure this topic so that we could teach our students to achieve the sustainable development goals by teaching to the traditional chemistry teachings, right? So this is what I'm saying, and you also you also agree that even my students is always going to be think that environmental chemistry means studying pollution after it has already done, right? Green chemistry is different. What is green chemistry? It asks us to prevent pollution at the design stage itself. So there is a distinction between that green chemistry and environmental chemistry. For examples, green chemistry asks, can synthesis be redesigned? Can we use catalyst? Can we use a safer solvent? Can we reduce number of steps? Can we avoid unnecessary derivatives? Can we reduce energy consumptions? Can we improve selectivity? So this change in intellectual role of the students. The student is no longer following a method which we provide to him, but the student begins to evaluate the method. This is where the chemistry education becomes the matter. And this is how I think that we should start our practical sessions, not to just giving them this is the SOPs, this is the old practical journals, this is the books from where you need to follow the methods, but we need to ask the students that you just evaluate the methods, evaluate this method. And once you evaluate the methods under certain parameters, so then we will find that my student is really it's a green chemistry, like he is studying our chemistry as a green chemistry. Can I ask to all of us, how many of our practical experiment ask students to comment on safety, waste, solvent use, or alternative methods? how many are practical experiments ask students to comment on safety, waste, solvent use, or alternative methods?
Sir, as per student, like, as you rightly said, sir, we normally talk and then the student says, okay, just show us the video we would like to see rather than performing. So we'll not waste the chemical. Honestly, that's on a, general note.
Yeah, but still, if I say that at the end of the practical session or at the end of that practical journal or in any experiment, we had one section that we call the result section. So where we ask our students to just put your results, like write your results. So whatsoever you perform, what calculations you do, what observations you find out. So just write down your results in either in all sorts of chemistry, like it will be a physical, analytical, inorganic, or organic. Is any university or is any college mentioning at the end of that result points whether they mention that comment on safety, waste, solvent use, or alternative method for this procedure?
No, sir.
Wow. Wonderful idea, sir. That should be there.
Sir, still not.
Sir, sir,
Hi,
hello.
ma'am. Yes, ma'am, please.
Sir, we are for the last 5 years, we are pursuing many green chemistry options. Like for titrations in UG level, we are doing the double burette method and not the burette pipette method because it lessens the waste generated. And then for the analysis work, we are doing the spot test and not the conventional method. And
Yes, great,
for
great,
organic
great.
analysis also, sir, we are not using the sodium metal now. For the last 12 years, we are using the sodium carbonate and zinc dust extract. So we are finding that there is lot of lessening in the generation of, so they are also safe.
Yes, great, madam. I think that this is the platform where we can share our experiments to each other, and we can say
And
that,
the
like being
results
a
are also
chemistry
very
fraternity.
good, sir.
Yes, very good, very good. So this is being a chemistry fraternity, we could achieve, like together we can achieve the sustainable goals. So I really congratulates to the this academic staff of this Amrata University. They brought all these teachers on a one platform where they can uh, like try to get to achieve the that sustainable development goals. So very good initiative, ma'am, and thank you for sharing with us. Right, but for now, I can say like that I think that these 3 points, the 3-4 points which I said, that we never ask our students to, after results, we never ask to comment on the safety, waste, solvent use, or alternative method that can be used for this procedure. Right. This is what if we just include in our traditional. Like I'm not saying that we need not to change the traditional methods of synthesizing or that doing the practicals, all that one. If we just ask them, if we just put these 4 points after the results, I think the mentality of the students will change. Now they will, instead of just following the SOPs, following the old journal procedure that we provide, they will just think at least 4 points, like for 4 points they will think if whether they like what is the safety of this reaction, what is the waste I'm getting here, like what is the solvent I use, what is the alternative method, whether there will be any alternative method for this. So at least student will try to start to think about things, right? So this is how we can achieve the sustainable development goals. Okay, so now I will from here I will take some 3-4 examples of a particular topics, particular branch of the chemistry where we can include the first, like we include like we can say techniques where we can say ki now my traditional topic is going to be changed into the sustainable to achieve the sustainable goals. So the madam Archana madam jo right now they was asking me, sir, whether there are some solutions to all of these things. So, ma'am, now I will try to make mention 4-5 topics where we can teach our students in such a way that we can ask them to achieve a sustainable development goals, and even if we incorporate these things in our teaching or in our syllabus, because that is not an addition to the syllabus, The same things we are doing, but we are just reshuffling or we restructuring. And this is what I said, that already we did a whole experiment. We asked them to write down the answer results of that one. With that, if we ask them to write down these 4 points, I think that will be an initiative towards the sustainable development goals, right? So my first point is, can we reframe the stoichiometry? I think this is a very basic topic, and this is the first topic that we normally taught to our students in very first lecture, stoichiometry, right? So can we change the reframe the stoichiometry from yield calculations to atom economy? I think till now, in our practicals, we had the yield calculation. Can we change it to them, to reframe them just to atom economy? So stoichiometry is often taught as on a numerical topics. Students calculate moles, limiting reagents, theoretical yield, percentage yields, right? So obviously these require the skills, but I think that these are not enough. Reaction may use a good percentage of it, but the poor atom economy. Right? So this means that even if the desired product is obtained efficiently, many atoms from the reactant may end up as the waste. So the things that we want to know them, what is the waste, now that we can correlate. So in my traditional teaching, like for a stoichiometry, if I want to know, like if my students want, if I want that my students should be able to know mole concept, limiting reagent, theoretical yield, percentage yield, balance equations, all the calculations he's known. But if I just turn it to be in a different one, that what is atom economy? So if I told them that the reaction may give a good yield, obviously he said that my reaction is 60%, 70%, 78% yield. Yes, but what about the atom economy? So if I said that even if the desired product is obtained efficiently, may atoms from the reactant may end up as a waste. So I think that this idea will change the student understanding of chemical efficiency. Right? So efficiency is not only about how much product is obtained. It is also about how intelligently matter is used. So I think that we can, even while teaching this stoichiometry or while giving all these mole concept and limiting reagent, if we just change our way, if we ask them to calculate for a reaction, which route gives you better yield by comparing, like if we can ask them that gives any student to any two routes for preparing the same product, like for a preparation of same product, give me two routes. Like we can do this activity in lab also, right? So we can ask them, give me any two routes for a preparation of products, and we can ask them to calculate which route gives you a better yield, which route has a better atom economy, which route produce more waste, which route use safer reagents, which route is more suitable for scale-up. What stoichiometry becomes connected with responsible production, right? So if we ask our students during the practical sessions about this one, so I think that the thinking of student is going to be like, we will be able to change the thinking of our students. Like we are not changing, we are not asking them that do not write the mole concept, do not write the limiting, do not write about the limiting reagent, theoretical yield, practical yield. We are asking the same thing. Like we are keeping the traditional things similar as it is, but with that we just want to turn these traditional things into the SDGs, like some SDGs, and by just changing this, by just asking them to these questions. So I think that this is how this stoichiometry concept can be reframed, right? Can we reframe thermodynamics and kinetics? Like instead of energy catalyst and process responsibility. See, what is happening in traditional, like this is how we normally teach thermodynamics and kinetics. Again, all the teachers who taught the thermodynamics, kinetics, they will correlate with this one, right? So thermodynamics and kinetics are not merely abstract physical chemistry topics. They are directly connected with industrial energy use, process design, and sustainability. When reaction requires high temperature and high pressure, energy demands increases. When catalyst lowers activation energy, the process may under milder condition. When selectivity improves, pure side products are formed and purification becomes easier. So with enthalpy, entropy, free energy, activation energy, rate law, Arrhenius equation, catalyst, if we can focus on energy efficiency, mild reaction, catalytic selectivity, process optimization, lower carbon footprints, reduce purifications, and industry relations, I think we will be able to teach or we will be able to reframe thermodynamics and kinetics into sustainable way. So we can ask our students while teaching thermodynamics, can the reaction occurs at lower temperature? Right? So see, one simple example. So we always taught students about the catalysis. We taught the students catalysis, and we always give an straightforward direction. The catalyst is the compound who does not take part in the reaction, but it speed up the reactions or it increase the rate of reaction. And while increase now, and when we explain how it increase the rate of reaction, we always say that it lowers the energy barriers, right? So it makes the reaction to be happens very faster. And then how we say while explaining all these ones, so we explain in various ways. But one of the best concept that we always said, we lowers the energy barrier, means we lowers the temperature of the reaction. Right. So while teaching the catalyst, we can give an examples, like we can ask our students, can the reaction occurs at lower temperature? Can catalyst improve the selectivity? Can reaction time be reduced? Can energy input be reduced? Can same product be made through a less energy intensive route? Can process optimization reduce waste? So while teaching thermodynamic and kinetics, if we can correlate these things, I think the industrial persons will be very happy because they are more interested to the right hand side points rather than to the left hand side points. I think how many of you will agree to me with this one, that the energy concern like industrial persons will correlate, they will be more interested into the right hand side points rather than the left hand side point.
Very right, sir. Very right.
Definitely, sir, towards right-hand side points.
Agreed.
Obvious. So I think the same points that we had on a left hand side, the same things we can taught in terms of the right hand side, right? And I think that for that we need not to change, we need not to add any like topics, any points in our traditional syllabus, right? So this is how we can convert, this is how we can go for a responsible chemistry rather than the isolate chemistry. So the traditional teaching, obviously, it has to be there. But with the traditional teaching, if we relate it with the industrial persons, industry, then we can achieve the sustainable development. Then we can be more responsible rather than the isolate. My favorite one, can we reframe organic chemistry? Like from reaction mechanism to the responsible synthesis. So obvious, organic chemistry is one of the richest area of sustainable integration. Student always learns mechanism, intermediate, reagents, and products. The functional group, reaction mechanism, stereochemistry, name reaction, synthesis, spectral identification. These are the all topics that we used to teach and taught, like we used to teach in organic synthesis, organic chemistry, and everyone, right? But I think the teacher can but the teaching can go deeper if we go for a sustainable way. So basically, every organic synthesis can be discussed through some additional questions. I'm not saying that this is what I'm saying, that every organic synthesis that we are teaching to them, that we are explaining to them, that can be teach in some additional questions, like how many steps are involved, are protecting groups are required, is the solvent hazardous, is the reagent toxic or corrosive, is the reaction catalytic or stoichiometric, what byproducts are going to be formed, can the product be isolated without excessive solvent use, can microwave, ultrasound, solvent free or aqueous method be considered where appropriate, right? So while teaching every name reactions, every organic reaction, every synthetic reaction, if we just add some additional questions to these students, I think we are going to relate, or we are going to interconnect with the disciplines. Like from organic chemistry, if I'm asking like simple things, if I'm asking that can be reagent toxic or corrosive, I think that we can directly correlate with some corrosions. Then students will open up his mind. Yes. What is meant by corrosion? So when we ask them, can microwave, ultrasound, solvent-free, aqueous method be considered for this reaction? Then again, he will go for a solvent synthesis, solvent selectivity. So if we just correlate, if we just add, if we just interrelate our topics, if we just add some few basic questions, few additional questions to our students while teaching the traditional like a syllabus. So I think that we will be very much successful to attain that SDGs again. Can we refrain polymer chemistry from useful materials to responsible material? So basically, what I suppose that polymer chemistry offers one of the best opportunity to connect chemistry education with SDGs. Obviously, students must understand polymerization mechanisms, molecular weight, crystallinity, glass transition temperature, structure property relationship. But what I thought, this must be connected with the present plastic crisis. Plastic persistence, microplastic, biodegradable polymers, mechanical recycling, chemical recycling, polymer sorting, circular economy, desire for end of life, right? So the very property that makes useful plastic can also make them the problematic. And this was, I think, that our previous slide where we said that every discovery has two stories. So obviously it's a useful, but at the same time it will be problematic. So like as I said, durability, chemical resistance, low cost or advantage during the use, but after disposal, the same properties may create environmental persistence. So we go for a low cost plastic, it will be a very dangerous hazards for an environment, right? So students should ask, like this is why the student should ask every time, why are some polymers difficult to recycle? What is the difference between recyclable, biodegradable, and the compostable? So again, I'm asking the questions. What is the difference between recyclable, biodegradable, and the compostable? We should ask our students, why does mixed plastic waste create difficulty? How this chemical recycling differ from mechanical recycling? How do additive affect recycling? What is the role of polymer design in reducing environmental burden? Right? So obviously, like what are the questions we are asking? They are not creating any anti-plastic thinking. We never ask that why we are creating plastics or which plastic is very dangerous for us. It's useful. We need to do. It's a discovery. It's a great discovery. But at the same time, we also ask them plastics are essential. Like as I said, plastic are essential in medicines, electronics, transport, food safety. So what our objective should be that they should develop a responsible polymer literacy. So we should be able to, like we are my aim is that being a polymer teacher or when I'm teaching polymer topics. So my aim should be that my objective is to develop responsible polymer literacy, right? Can I reframe analytical chemistry like chemistry as evidence for public decision making? So analytical chemistry is often taught through titrations, gravimetry, chromatography, spectroscopy, and instrumental methods. Obviously, these are essential, but it should be presented as the science of evidences. Is the water safe? Is the medicine genuine? Is food adulterate? Is the soil contaminated? Is the industrial discharge acceptable? Is the air quality dangerous? Right? So instead of asking them to just do the titrations, gravimetry, chromatography, spectroscopy, and instrumental methods of analysis for our, like a sample, like our laboratory sample, we can just turn all these reactions, we can turn all these practicals into the evidence for public decision making. We can just ask them, is the water is safe? Water you are drinking, is it safe? Is the water medicines are there? It is a genuine medicine. Water food you are eating, it is adulterate. Then how you are going to go for food adulterations? Water the soil is there, whether it is a contaminated. Right? So simple practical. The same practicals we are doing, but we can we can turn these practicals into the instead of just as an part of analytical chemistry, we can make them as the evidence for a public decision making. So this is how, as I said, we can reframe some topics which we traditionally teaching to get like into that in such a way that it will be achieved, or there we can say there will be it will help us to achieve some sustainable development goals. Can we reframe electrochemistry? Take batteries, hydrogen, corrosion, and energy. Right now, it's a most future-oriented branch of chemistry, electrochemistry. So obviously, it's electric vehicles, batteries. Right now, today's always everywhere we are finding batteries, fuel cells, electrolytes, sensors, corrosion control, energy storage, green hydrogen production. How many of us, while teaching electrochemistry, we correlate everything with this current applications? Like how many of us, like when we taught some, for example, if we taught some batteries to the students, how many of us correlate output of these batteries with the EV motors that already in the market, and then we can say what amount of output we require to run a car, to run like you can say run vehicles, and then how it is how the structure of that batteries and the material of that battery is going to be changed. How many of us just taught to our students in this way? I think how many of us is like out of us, how many of us we used to teach electrochemistry? That there will be many people who taught the electrochemistry, right? So while teaching electrochemistry till now, whether we directly correlate, whether we directly interrelate these topics, redox reaction, electrode potential, Nernst equation, conductance, electrolysis, galvanic cell corrosions to the industrial problem. Have we ever tried to correlate this one with this one? I think very few of us, right? So, like reframing electrochemistry doesn't mean that it should be changed everything. Like redox reaction has to be omitted, electrode potential, this has to be removed from the syllabus. No, it has to be there. But when it has to be there, when we are discussing this topic, with that, additionally, we need to interrelate this topic with the SDGs. And then students need to think, then we need to ask our students how you are thinking about this interrelation. This is what it basically called the reframing of to achieve that sustainable goals. Can we reframe inorganic and coordination chemistry, like catalyst materials and biodegradable biological relevance? So basically, what we expect from in inorganic chemistry, we expect periodic trends, bonding, coordination compound, crystal field theory, like safety, organometallics, bioorganic chemistry, from our students. And this is what we always taught. So, see, coordination compound can be connected with the catalysis, medicinal chemistry, enzyme models, sensors, materials. Transition metal can be discussed in relation to catalytic selectivity, hydrogenation, oxidation, environmental remediation, energy application. Bioinorganic chemistry can help students to understand iron in hemoglobin, magnesium in chlorophyll, zinc enzymes, metal toxicity, essential trace elements, right? So this is how we can just shift a gear. We can just shift our way of teaching with just a slide addition of a view of like a slide addition of our view, so that a student should think like student should, it should not be that whatever we are saying, whatever in syllabus, it is in syllabus, but it should be it should be taught in the sustainable way. That's the most important. Can chemistry laboratory transform from procedural compliance to scientific judgment? See, I'm seeing these two things. What traditionally we are rely on procedural compliance. How many of us is not agree with this one? I'm talking about the practicals that we are taking, that we mostly thought it will be a procedural compliance.
Absolutely, sir. We are doing a procedure compliance.
Can we go for a scientific judgment? This is what traditional laboratory students are doing. Following instruction, observe color change, record readings, calculate results, submit journals, right? See, laboratory is the heart of chemistry education. I think everyone will accept this. But in many institutions, laboratory learning has become too procedural. Students often know what to do, but not why they are doing it. They know the expected color change, but not the meaning of the analysis. They record reading, but may not examine error. They submit journals, but may not reflect on safety or waste. So how we can transform chemistry laboratory into three-dimensional way? First thing, scientific accuracy, safety and environmental responsibility, interpretation and communications. So this is a three-dimensional way. This is how we can transform. For examples, after an organic preparations, we can ask our students what was the percentage yield, what was the atom economy, which solvent was used, what hazards were involved, what waste was generated, how can the experiment be made greener after a greener, right? Once the titration is finished in analytical chemistry, we can ask, what is the reliability of the results? What are possible source of error? What does result mean in real context? Right? So just by adding these few questions, we can entirely change the perspective of the students to looking towards that practicals. Like right from the procedural, like it's not only procedure to just add a few things like few solution from burette to the control class and just observe the color change. It's not, this is a procedure compliance, but when we ask the students about the errors, when we ask about the students about the procedure, when we ask the students about the error, then the results, reliability of the results. So now the contest, he will go for the scientific judgment. Right. So this is very simply we can change our traditional laboratories into the SDGs laboratories without making the infrastructural change, without making the like a change in the solve chemicals and all that one. Just by adding a few questions, we can change the mindset of the students. We can change the goals. We can change the procedural parts to the scientific judgment part. Right. I think this is the most of ones will obviously correlate. It's a recipe-based practicals, or practicals are recipe-based practicals. Can we make these recipe-based practicals to the inquiry-based practicals? Like what is happening in recipe-based practicals? What we had: aim, chemicals, procedure, observation, calculation, results. This is our recipe, right? Can we make this to the inquiry-based practicals? Instead of writing aim, now you can just see, if I just change the way, if I just change these titles, that titles is changing the thinking of that students, or it is changing the recipe-based practicals to some inquiry-based practical. Like instead of aim, if I'm just giving a problem and a hypothesis, method selection, data collection, error analysis, interpretation, sustainability, reflection, recommendation. Right? I can give simple examples, right? So we hadn't seen everyone, like in many of the universities, many of the colleges has a simple experiments of water hardness. So we had as aim of that practical, determine the hardness of water. Can we redesign these practicals of this rather than recipe books? We can give 3 samples to collect it from a local source. And then we can ask, determine hardness, compare the samples and recommend which sample required treatment before domestic use. Did we do anything else, anything new? No, we had not did anything new. The same thing that we was asking him to determine the hardness of water. We asked him to determine the hardness of water. But the way we just changed, instead of giving one sample, we asked him to bring 3 local samples, determine hardness, compare the sample, and then you recommend which sample required treatment before domestic use.
Yeah, very right, sir. I would like to say here, we tried to do this thing to hardness of the water. We ask all the sample, bring your own water from the home, and then find out the hardness of the water. Instead of we giving the unknown sample, we ask them to find out, the hardness of the water of your sample. So that's
okay. So great. So do you add recommendations?
recommendation in the sense we normally suggest, we normally ask, okay, from which, where are you coming and what is the source of the water, from where are you getting, like even if you're Delhi, are you getting the Yamuna water, are you getting the water from which source? So just let me know the sources you are getting the water.
Yes, great. So if we with this one, if you just add them that given just recommendation which before like which should be required treatment before domestic use, right? So if we just add if we had some these simple practicals, but if we just change this change the way of doing these practicals in a simple way, traditional practicals we are doing, we are complying our we are syllabus, we are completing the syllabus which is mentioned, like with practicals which is mentioned in our syllabus, determining the hardness. Yes, we are determining the hardness, but while determining the hardness, we are doing in such a way that it will also achieve the SDGs.
Right, sir.
Right. I think that this is the most of researchers will always going to be correlate with this. Research scholars and sustainable chemistry. This is my old research question. Can this compound be synthesized? Now I think that better research questions will be, can it be synthesized safely, selectively, efficiently, and sustainably? Like, what is the impact of that? What will be the old research value? It was a novelty, because can this compound be synthesized? If it is synthesized, that will be a novel way. Novelty alone. But when I say that synthesized safely, selectively, efficiently, and sustainably, my value is going to be better one with novelty, with the relevance, safety, scalability, and the sustainability. So just changing this type of question, just changing the way of questions, can this compound be synthesized? If I change this question, can I change synthesize safely, selectively, efficiently, and sustainability? I'm not only changing my novelty, like I'm not only achieving my novelty, but at the same time, I'm achieving some better research value for my research. So my suggestions, those who are doing current research also, my suggestion is that just go and just ask yourself, this question, can your hypothesis will be changed in such a way so that you can, like those who are doing or those who are interested for a research and planning for a research, they can they can change their hypothesis in such a way, in simple way, because you are obviously you are doing the same things, only we are doing it in a little bit a different way so that we can achieve some sustainability goals. See, curriculum designing doesn't mean that we want to add a burden. Basically, it's not the burden adding. See, solution is not to add one more heavy units. And this is the things which I already initiated. Like initially, where I already said this. Solution is to redesign the way existing topics are taught. When solvents teaching, when we discuss teaching about the solvents, we should use the solvent safety. When we're teaching catalysis, we should discuss about the energy efficiency. When we're teaching adsorption, we should discuss about the water purification. When we're teaching redox reaction, we should discuss about the batteries and corrosion. So, like we are not teaching. Like I am not suggesting that we should teach the SDGs as the decorations. We always supposed to be. So just we want that teaching the chemistry through meaningful sustainability contest like this. Like if we want to teach the polymers, we need to discuss about the recycling and end of life uses issues. So by adding some more topic, it's not like it's not to achieve the SDGs. It's not a way to just convert or to go for that the sustainable chemistry or for the green chemistry, but it just to just redesign, just rethinking for or the teaching the students these topics by some different way or by we can say some different methodology by correlating, interrelating with some practical, social practicals, social concepts, or you can say industrial practicals, that we can just teach our students about this in a different way, so that we can achieve that SDGs or Sustainable Development Goals. So today my aim was that to just explain how we can reframe our curriculum, existing curriculum, without disturbing the traditional syllabus, to just convert it into the syllabus where we can achieve some sustainable development goals related with the chemistry, so that the society will not blame us that the chemistry teachers or the chemistry peoples are the mostly responsible for the pollutions, right? So I can use one just task for all of you. You can redesign any chemistry topic for SDG oriented teaching. I have given you some examples how we can reframe some syllabus, like if it will be organic chemistry, stoichiometry is there, then catalysis is there, thermodynamics is there, right? So you just redesign any particular topic. You had some particular topic which you are already teaching. Can you redesign for an SDG oriented teaching way, right? So you can take any topics from this one, like you can take acid-base titration, chemical kinetics, electrochemistry, coordination chemistry, any topics you can take from them one. You can just ask these questions and give answer to these one. I think that you will be able to convert, you will be able to redesign the syllabus, your topics, teaching topics into the SDG oriented teaching. Right? So finally, I want to say the future of chemistry education lies in teaching students not only to ask, can we make it? But also, should we make it? How should we make it? And what happens after we make it? So thank you all for your patience hearing and for your attentiveness for whole sessions. And I will like to thank the organizer for giving me opportunities to express my views towards this particular topic, and just to help or to just give further steps to achieve some sustainable development goals to a chemistry curriculum. So thank you all. And anyone wants to have any like I can say express views regarding this topic, anyone wants to ask something about this, so I will be very happy to share my discuss the participants.
Hello, sir. Thank you so much.
Thank you, ma'am. Thank you.
Yes, participants, anybody would like to interact, would like to ask anything?
Sir, wonderful. It's a wonderful lecture in the sense it's a very practical approach, like, how we should think and should teach our student in a direction. So it's a wonderful way. And
thank you, ma'am.
Thank you, sir. Thank you so much. And
thank
so,
you,
as simple again, I said this, in a curriculum, we normally follow the curriculum.
Obvious.
We try to correlate few things, but still at the end of the day, if I'm doing mixture analysis, whether I'm doing organic synthesis or I'm doing simple bromination, acetylation, so all product at the end of the day are going in the bin. So
obvious.
What should be the solution for that?
See, ma'am, actually, that's what I said. Traditionally, concept or traditionally things we cannot avoid. Even if you are going for industries, you need to synthesize a compound, right? And even if you are going for some synthesis of a tons of compound, you need to taste many compounds, and from that like a many thousands of ways, thousands of product formation, you are selecting one of the products for a better way, like a better products or a base product. So you cannot avoid the like a traditional way for a synthesis. Obviously, that is one of the things is there. Can we design a practicals where we can control, or we can say the use of the solvent-free use of the less hazardous chemical starting materials, as one of the madam was saying that they had like avoided the use of the sodium for testing, and they started to use that sodium carbonate and zinc gas. So can we develop some process that is already like we are doing some obviously for that sodium, and for that analysis we required that one, right? We required that sodium. But can we design some safer chemicals? That can we design some safer way for doing the practicals, which is traditionally which is required, because student has to know about the methodology. Student has to know about that. Student has to get the skills of synthesis. He has to know about the stoichiometry. But while doing that one, can we have some alternate ways? That I think that if we this platform is the best way. This platform is the best method to collect all this. If it's, you people all have these kinds of the practices you are doing in your colleges, you are doing in your universities, institutions. If you can collect, if you can connect with each other, you can collect them, and if you can share with each other, I think that will be a fruitful things from here. You are taking.
Thank you, sir. Thank you.
Sir, hello.
Yes.
Yes. Yeah.
Actually, sir, we are the teacher and we will try to train the student regarding SDG. But what about the big companies, and they are producing the chemicals and wastage, and they are producing a lot of polythenes and so many. You see that mobile cases, mobile covers, they are the plastic. Yeah, these are going to be garbage in environment. What about that ESDG? Who will the responsible for the how it is going to trend for the ESDG?
So again, the answer is that we are like what are the procedures those people are following. Like for example, you said about that mobile plastics and all that one, like mobile plastic cover. So preparation of that mobile plastic, the plastic which is required for that mobile cover, that preparation was given by some chemist. Do you agree with this?
Right.
Right. And since this is what are the procedure is there with this one, like it's a kinds of SOP is there. If being a chemist, you are able to give some alternative ways which will give the same quality of plastic, same property of the plastic, but that will be in safer way. So it's a like it's a task to our chemist itself that we need to provide. Like obviously because they do not have. So they do not have their own methodology. The methodology is given by us itself. We provide chemistry itself. So now, if one methodology we have given to them for preparation of that particular plastic, can we have other methodology to prepare the same kinds of plastic with the same properties and same like the same costing and everything that they require? So now that's our way, and now that's our task.
So what about the waste management? It's also going to belong ESDG if we do that waste management.
So this is why the green chemistry comes there. So this is why the environmental chemistry and green chemistry is a distinction. I think that in one of the slides I told, basically now whatever happened that we cannot control right now. So waste management and all that one. Because whatever we are doing for waste management, we need to do something, like we need to involve energy into that one. And that is, so instead of wasting energy into that one, can we redesign? Can we design a simpler way? Like, can we go for a green chemistry rather than an environmental chemistry?
Yes, in case of hardness, we suggest to students bring your samples from home. But finally, sir, if we do that experiment, hardness of water, we use the EDTA and NOH, everything, and that is going to decant in, and finally it's going to waste management. So we have to also focus on waste management. What about you?
See, actually, traditional practicals are there, so we basically we use many like we do a many practical where the titrations are involved, right?
Yes, sir. So many there your NOH and it is going
What
to be
is
counted
what
every year.
what is our aim is that our aim is that we need to taught our students how to do the titrations. So by like if we teach our students by doing 10 titrations, 10 experiments, or if we are doing by if we are teaching our students by doing some five titrations, there are 5 experiments.
Okay.
Everywhere we are doing some EDT and all that all kinds of practical. Like you said for hardness and all that one, right? We already taught them for doing all these ones. Can we have some alternate ways for that one? This is how I said you need to redesign your thinking. And the last slide I said that can you have these kinds of being and chemistry teachers? Can you thought being and fraternity chemistry fraternity? Can you think can I redesign this experiment so that that will be a lesser like that will be less consumptions of chemicals and less like methodology is there. So can I have some alternate methodology?
Yes, sir. We have to redesign. That is the.
So I think that being a chemistry teacher, that is our responsibility. So we can redesign, we can reframe some topics so that we can talk to our students in different ways. If they thought like how you are thinking, like what you are thinking, same way your student should be thinking. Your student should be asked, sir, why we are wasting these chemicals? If I know the skills, same skills in previous practicals, now why I'm wasting this when they're wasting this one?
Yes, sir. In my research, sir, I just use the sustainable materials, biopolymers, and water. Just 2 things I generally use in my research, and make the some materials and try to train the PhD students. I don't want to use the acid and NOH like that.
Great, sir. So I think that if you can share all your experience and all your the materials with the other participants on this platform, I think that will be a great help for other ones for other one also. And they can even start to think in that way. I think so. So
yes,
if you can, if the coordinator madam can correspond with this ones, and they can connect all these methodology like that one of the madam was telling about that one of the experiments sodium extract for sodium extract they are using some alternative way. So if these kinds of idea connected, if these kinds of idea you can collect and you can share with everyone, and also you can share with the other university peoples. So that will be helpful for all the chemistry peoples.
Yes, yes, sir. Thank you, sir.
We will take the note of this, Banima sir.
Yes, please.
Now,
because I think that people has a very good ideas. Yes,
only
thank you.
the thing is we have to start the other session, and the next research person has already joined and he's waiting.
Yeah, thank you very much. Thank you, ma'am.
Thank you so much, sir.
Yes.
Just wait few minutes. I think one of the participants please propose vote of thanks.
Dr. Ganesh,
Ganesh?
please propose vote of thanks. Dr. Ganpat.
Yes, sir. और आवाज आ रही सर?
Yes.
Hello, आवाज?
Yes.
जी. Good afternoon to one all. I am Dr. Ganpat Singh Argal, Assistant Professor from Government CMD College, Maharajpur, District Chhatarpur, MP. It's my privilege to propose the vote of thanks. This is the wonderful occasion. On behalf of the MMT and Sant Gaikwad Baba Amravati University, I extend my heartfelt gratitude to our respected Sir Dr. Vishal for taking the time to be with us and for sharing such valuable thoughts and inspiring words. The lecture was very informative and valuable. We get more knowledge by the lectures. Once again, thanks you, sir, for your presence, encouragement, and blessing. We truly appreciate it and your time and effort. Have a nice day, sir. Thank you very much,
Thank
sir.
you. Thank you very much.
Thank you, sir. And with the kind consent of Professor Bhagwan, sir, I would like to declare that this particular session will go here and we
Yeah,
can
thank
continue.
you. Thank you. Thank you. Thank you, Colonel ma'am. Thank you.
Hello, Professor Ishram, sir. Hello, Dr. Rahul, sir. Dr. Rohan, sir.
Hello, good afternoon, everyone. I am here.
Good afternoon.
Hello,
Good afternoon.
sir. Good afternoon.
Okay.
Sir, first of all, we are extremely sorry we have taken the 10 minutes from the allotted time.
No issues, no issues. I am eventually the last one.
Shall we start with the session, sir, if you could permit?
Yes, sure,
So,
sure.
friends, let us warmly welcome Professor Rohan Meshram, sir, once again to this refresher course and to particular to this session. On behalf of Malviya Mission Teacher Training Center, Sir Garge Baba, Amravati University, and our course coordinator, Professor Manisha Kudape ma'am, and all the participants, sir, I extend my warm welcome to you once again and request you to please start with your session. Sir, please.
Okay, thank you, sir. Let me share my slide. Okay, so is my screen visible to everyone?
Yes, sir. Yes,
I
sir.
hope it is.
Yes, sir. Yes.
I am audible as well, right? सुनाई दे
Yes,
रहा है
sir.
क्या बोल रहा
Yes,
हूँ?
sir.
Yes.
Okay. So guys, I'm back. Whether you like it or not, I'm going to talk for another 1 hour or so. So, do you remember what is that
You're not audible, sir.
Okay, now am I audible?
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
Oh,
Now audio.
sorry. Huh?
Yes, sir.
Okay, okay. You should have told me. Right? Okay. Just a minute, huh? Okay, so let me begin once more. We are here again to talk on molecular dynamics simulation. And in our previous lecture or in our previous session, we dealt with, setting up and running the simulation, right? And these are the 5 steps that we followed. Like we obtain the files in GROMACS readable format, and then we merge the topologies to compile the protein ligand information together. Then we begin editing the system topology. This step kind of enabled your GROMACS to recognize protein and ligand together. Then we created a virtual box around your protein ligand complexes. And subsequently, we added water molecules in the protein ligand system. And then we perform charge neutralization, wherein we neutralize the charge by adding counter ions like sodium and chloride ions in order to make your system charge-wise neutral. And then we perform energy minimization, and this energy minimization kind of removed the clashes that might happen between the water molecules that you have added and the protein ligand system that you have created. Then we went on indexing the ligand. So we need to index the ligand in order to apply position restraints on the ligand for the subsequent equilibration steps as such, right? So we begin with generating the position restraint for ligand. Then we again edited the topology. Then we created the final indices or indexes that enabled GROMACS to treat the protein ligand as a single biological complex, right? And we then perform, I kind of demonstrated you as to how can you automatically create a pipeline wherein you can run the equilibration simulation in 2 stages. In first stage, we equilibrated the system for 100 picosecond, which on, if you are using CPU system, it might take 10 to 20 minutes, while another 100 picosecond equilibration system was performed. That might also take another 10 to 20 minutes. And finally, 1 nanosecond production run was performed, which eventually took 2 to 3 hours. So in short, this is what we have done, right? So using this GROWIN, or what we call it as the Windows version of GROMACS, what were the problems that we eventually solved? The problem was like GROMACS require Linux as well as command line expertise for any user to use it effectively. So now, even if you are using latest Windows like Windows 11, it still needs Windows subsystem for Linux that we call it as WSL, right? So this was a kind of problem that many of the non-bioinformatics, or you can say people with limited computational experience face, right? So the solution was like, why don't we cross the platform barrier and port GROMACS into Windows operating system. That was the basic idea. So that there should be no need of this Windows subsystem for Linux, and our software will work on older versions of Windows as well. Well, say for example, Windows 10, Windows 8, they don't have such Windows subsystem for Linux. Therefore, porting GROMACS onto Windows operating system solved this problem, right? And we kind of created a separate installer for CPU PCs and GPU PCs. The objective of doing that was to kind of enable anyone with minimal system requirements to at least learn these MD simulation procedures, right? And next problem that we solved was we created a guided workflow for topology generation, the entire MD simulation protocol that includes topology generation, solvation, charge neutralization, followed by the conventional molecular dynamics protocol, like minimization, followed by equilibration and production. So, but still, my friends, there are still problems to be solved, right? Say for example, this is what usually happens. We kind of institutes like Bioinformatics Center at Savitribai Phule Pune University, or any computational biology group that is involved in creating softwares for you can say chemical audience, or you can say audiences that are more confined towards biological application. Well, these labs tend to release the software, and that is what we usually do. And then we try to see how is that the user community react to it, right? And when we kind of released this Grovin software back in 2023 or so, well, I thought that okay, things are solved now. People will start using it. But the moment I start following the students that were using it, the moment I started following the researcher that were trying to use this software, I understood that there are a lot of things that are still needed to be addressed. Well, there are a few things that I would like to first discuss with you. Well, what are the problems that non-technical researcher or a student or even faculty face when they start to use complex programs like GROMACS or even NAMD. So the first and foremost and the most important problem that exists is that there is a barrier for audience even from experimental background. Okay? So people from experimental you can say, or researcher or even faculty or students from experimental background, they are usually trained to do things visually, right? See if the color changes, see if there are vapors, or we kind of heavily rely on what happens in the lab, right? But when it comes to molecular simulations, everything becomes imaginary. And the only thing that you usually see is that stupid command line system, that command line window, and it seems to be intimidating for the newbies despite their scientific expertise, right? The second aspect of difficulty that people face in MD simulation adoption is the steep learning curve. So the thing is that when I have demonstrated you how is that you use GROMACS, most of the time I have bombarded a lot of commands. We have copy pasted those commands eventually, but if you try to write them, the things become quite complicated. The user kind of must first learn the command console before he start learning molecular dynamics. So the beginners in this field, spend more time learning the operating system rather than understanding the molecular dynamics concept. So this creates a kind of delay in directly jumping into MD simulations. The third thing that I noticed was that when you perform MD simulation, a complete MD workflow, starting right from creating the files to ending up with running the production simulation, that complete MD workflow require many individual commands. Okay. And if you explore GROMACS on your own, each command has numerous options, and each and every option has got multiple parameters that can be optimized. So these things, eventually becomes quite confusing, right? So even for our simple protein ligand simulation, the simulation that we set yesterday and tried to run it, so there were commands like pdb2gmx, then edit conf, then solvate, grom pp, j9, mdr, and whatnot. So poor beginner usually get exhausted with all the steps, all the workflows, and everything, right? So this is next thing. You might have also noted that when we finished running our simulation, so there were a lot of files that got accumulated in your folder. Well, for example, to say it simply, a typical simulation generates many files, right? And as a newcomer, it is really very difficult to keep track of what are the input files, what are the output files, and it is really very difficult to initially make a part कि भाई इसमें से input कौन सा है और output कौन सा है, right? So this creates a lot of confusion. Okay, so now how these things can be handled, how we can kind of make things more simpler, how we can make the life of a newcomer who is trying to learn MD simulation, how is that we can make his life more simple. Okay, there is one solution, and the solution being, my friends, we can develop a graphical user interface. We can make the boring command line interface colorful, make it graphical interface कुछ इस तरीके से बनाएंगे so that things might become easier. No one has to remember things. No one will have to remember the commands or remember the values that we are supposed to put in there, right? So that is exactly what we did next. We tried to create a kind of easy to use, robust, and very effective graphical user interface. And that is what, my friend, I'm going to demonstrate to you today, right? So that is what, my friend, this is what we call it now. We call it as GROMACS Pro Suite. It is a graphical user interface for GROMACS. Now let us get things clear कि भाई ये जो नया वाला इंटरफेस है जिसके बारे में मैं बात कर रहा हूँ, where to obtain and how to download that thing. Okay, so where to obtain, of course, जहाँ से अपन ने GROMACS अपना ग्रोविन डाउनलोड किया था, we can obtain it from the same source, right? You can just open any browser that you have with you and just type GROMACS.
Sir, excuse me, sir.
Yes.
Sir, you haven't shared your screen yet, sir. Kindly share your screen, sir.
Okay. ठीक है. Okay, now is it visible?
Yes, sir. Yes, sir.
I am audible as well, right? So now how is that you download this GROMACS Pro Suite? Okay. So this GROMACS Pro Suite can be downloaded simply by searching this, right? And you would be taken to the SourceForge website, right? And once you are here on the SourceForge website. Just wait for a while. I think the internet is slow on my side.
Sir, is this a open source software or it is commercial, sir?
This is an open source software. We have placed it on SourceForge platform so that everyone can download this software for free, use it for free, right? And anyhow, maybe when the internet return, we can come to this step again. I have already downloaded this software, so maybe I will show you, right? Okay, ठीक है. So now what are the operating system that are supported by this software, right? So this Gromax Pro Suite, well, it support both Windows as well as Linux operating system. Now coming to the prerequisites, that first thing that you would need to use this graphical user interface is that you should have a pre-installed command line version of Gromax, what we call it as Grovin, that we were using yesterday. तो वो आपको आपके पास में रहना जरूरी है. Then if you are using the GPU version of this Gromax or what we call it as Grovin, then you should have graphics card. Specifically, we have tuned this software to work with NVIDIA graphics card. And if you have graphics card, of course, you might also need CUDA accelerator so that you can use these things effectively. Third and important another prerequisite is that all development happened in Python. Therefore, Python 3.10 is necessarily to be installed on your computer, right? So for best experience, we recommend Windows 10 operating system or above of Windows 10, Windows 11. That is excellent to be used along with this Gromax Pro Suite, right? We have kind of tested the GUI in Windows 8, but not below it. So I would recommend कि Windows 8 और above के ऊपर ही आप ये वाला सॉफ्टवेयर यूज करें, ठीक है? But for smooth user experience, we advise a system with 16 GB RAM, and system with 8 GB RAM will be also sufficient, but things would get tricky if you kind of try to do some heavy calculation. Now, how do you install it? Installation is quite easy. Basic fact is you don't require any installation at all. Once you download the software, just place your software in that working directory, open it and start playing with it, right? So being said that, now my friends, let us roll. I will show you the demonstration. I will begin the demonstration. Okay. So this is what it is. Let us begin. So this is, my friends, when you double click this Gromax Pro Suite software, when you download it, this is how it will open, right? So the very first screen that you see is the what we call it as the dashboard. Now the dashboard is you can say the very first, and you can say it will kind of guide you through everything that is happening in your software, right? The thing is that whatever features and functionality that we are offering in this software, well, that are kind of placed in a series of tabs. We call it as tabs or tools. Okay, so there are multiple tabs that you can see. Okay, and these tabs can then be there are buttons like over here, which you can navigate through various tabs, right? So over here, you can see we have provided features and utility that monitors the computer usage of your PC, like how much CPU is being currently used now, how much RAM is being utilized, how much disk space is being utilized, right? And we are also providing this, you can say, a monitor bar at the end of this dashboard. So the thing is that this bar will kind of warn you if your system is facing heavy workload as such. Okay, so if the color of this bar is green, that means that the system is normal and all the modules in your software are working effectively, right? But the moment you use this software at its fullest extent, this will start to turn red if CPU is being used at way can say बहुत ज़्यादा अमाउंट में अगर यूज हो रहा होगा तो ये रेड हो जाएगा. So now what to do if this bar turns red? ठीक है. So don't worry, your system is not going to crash या फिर सॉफ्टवेयर क्रैश नहीं होगा, आपका सिमुलेशन क्रैश नहीं होगा. It is just a kind of indication that the CPU or the RAM space or the disk space is being utilized at the maximum level the system can afford. Okay, so my friend, now let us begin using this software. तो पहला स्टेप है आपका to create the files or to create the receptor and ligand molecule into PDB or you can say GROMACS readable format as such, right? तो इसके लिए आपको काम एक बहुत सिंपल करना है. All you need to do is to go to this browse button and select this. We are going to use the same example that we have used yesterday, right? So this receptor.pdb contains the information of your protein molecule. You need to browse and select that file, just hit open, right? Then select, we can use this ignore hydrogen dash, ignore hydrogen utility so that hydrogens would be ignored, right? And then you can push this run pdb to gmx command, and this will eventually initiate the pdb to gmx process, right? Next thing that you are supposed to do is to select the force field that you are supposed to use. So in our previous lecture, we have used this CharMem27 force field. Therefore, this CharMem47 force field will be used in this lecture as well, or in this demonstration as well, right? So this force field is present on 8th option. Therefore, we would type 8 over here and hit this send button. Okay. Now, the software is kind of asking you what water model you are supposed to use. Okay, so we would use the TIP3P model that is recommended, which is on first option. Therefore, we would again type 1 over here, then again hit this send button. Okay, so now my friend, we have kind of created, if you sort it by date modified, now you can see that we have created these 3 files. This conf.grow file contains all the information of protein, position restraints that are required for the atoms that are there in your protein molecule, and a topology file, or what we call it as the system file as such. Okay, तो ये 3 फाइल अपन ने अभी तैयार कर ली है. Okay, so now we also have ligand Therefore, to process the ligand, we need to activate this process ligand module. Again, browse your ligand molecule, open it, and you can simply push this run edit CONF button so that your PDB formatted ligand would be converted into a GROW formatted ligand. Now you can see over here, lick.grow file has been created, right? So these are the two steps that we began yesterday. Okay. So in this way, my friends, we have the protein as well as ligand in GROW format. Okay. So next thing that we are supposed to do is that we need to merge the topologies of protein and ligand. Okay. So for that, in our previous session, I showed you that we have used, say, some different software. But over here, we are providing kind of inbuilt text editor wherein you don't have to go anywhere outside now. All the text editing, you can do it right in the software itself. Okay. So what we will do, we will open this GROMAX command that we have been using in our previous demonstration as well. इसमें से ढेर सारी चीजें अपने को कॉपी करनी पड़ेंगी अभी. Right. Okay. So what we are supposed to do is that we are supposed to now combine the information of protein as well as ligand in a single complex as such. So इसके लिए we need to open this conf.grow and ligand.grow file that contains the information of protein and ligand. We would hit open. Okay. And if you remember, in our last demonstration, we copied all the information of ligand that is present on this 33 line. We have copied it and we have then pasted at the very end of the protein file, right? So this is the last atom of your protein, right? And I have pasted it using Control V, and I will align all the columns so that now the protein and ligand information is in the same file. Okay. Now what we need to do is that we now know that ligand information is there on 33 lines and the protein information is there on 50 lines. So we need to add these two numbers so that the GROMAX will understand that the entire protein ligand system contains 5083, or you can say 5083 atoms. Okay, so we have done two things. We have updated the protein, protein coordinate file with ligand information, as well as we have updated the number of atoms that are present in your protein ligand complex. Okay. So now after doing so, you have to save this so that the information remains there. Once you close this conf.grow file, we no more require this ligand ka grow file. Therefore, we would again close it. Okay. Now we have kind of updated the information in the coordinate file, but your topology file is, still GROMAX don't know what we have added. तो इसके लिए अपने को अपना topology file भी update करना पड़ेगा. And the topology file is in form of this topol.top, right? So now we need to tell like what are the parameters for the ligand. तो अपने को यहाँ पर at this place we need to tell our GROMAX what is the parameter or you can say where exactly is the topology information of your ligand located. Okay, so by adding these two lines, you are telling like, okay, this is where the ligand topology is. Okay. The next thing that you are supposed to do is to scroll very back down and update the list of molecules that are there. We have one ligand and the name of that ligand is Lig. The number of ligand is 1. So last time someone was kind of asking, what if we have 2 ligands? Okay, you can update as many ligands over here as possible. Right? So we have deliberately left these things on the user to do, as automating these things might have become really very difficult. Right? So this is what we have done. We have updated the ligand list, the list of molecules with ligand, and we have updated the ligand topology as well. So these two things are very important to get done at this stage in your protocol. Right? All you have to do is to save it and then make sure you close this topol.top. Okay, now we will also have to make sure that ligand.itp file is having the right information, right? So what we will do, we will open this ligand.itp file and we will make sure that the name of the ligand over here is Lig3. So we have the right file in right format. Okay, so after making sure, you can even close this. Okay, my friends. So now what you need to do is that next thing, of course, we need to define the box, right? And to define the box, we can use this define box tab. यहाँ पर आपको अभी जो edit किए हुआ वाला protein ligand information है in this conf.guru file, you can select it, you can open it up, okay? And you can keep everything else as default and just push this run edit conf button. It would run the Gromax edit conf command in the background, and it would generate a virtual box around your protein molecule. So this virtual box, you can say these are the dimension of the virtual box over here. Okay, this is the center of the box, and these are the vectors values that are required. These are the box angles that eventually defines the size of your box, and these values are very important when it comes to implement the periodic boundary conditions. Okay, so nothing would be shown in your VMD, but these things are set in the background. Okay, so now a virtual box has been defined in your system. Okay, so next thing that you are supposed to do is to now in that virtual box we would start to populate the water molecules. Okay, so abhi kya karte hain? For doing that, we can use this solvation tab, right? And in this solvation tab, we would now select this newly created box file. We would open it, right? And we would browse and select the topology file that we have recently updated, right? Okay, and let the name of the output file be as it is for the sake of convention, and just hit this run solvation command. Okay, now you can see that number of solvent molecules that are added are some 9,621. Okay, so now let us also let us now at least see if everything is working properly or not. Okay, let us come out of our software and see if we have a solvated water box ready or not. Okay, as you can see, water box, the protein is quite well solvated. Okay, so we are in the right direction. We can close it. Okay, now next thing that we would do is that we can again open our topol.top and see indeed if the water molecule list was updated यहाँ पर, right? So the list is indeed updated. So that means our topology file is also well modified, right? तो ये हो गया अपना solvation. Now the protein has been solvated properly. Now let us perform charge neutralization, and we do charge neutralization by adding ions, right? तो इसके लिए अपने को एक MDP फाइल लगने वाली है, which we already have in our working directory. Select ions.mdp at this stage. Then you can use this solvated system that we have recently created. Just browse and open it. Over here you would need topology information. तो उसके लिए topol.top file open करते हैं अपन. Okay, and let us keep the output of the file name to default and just hit this generate TPR button. And now you can see, my friends, that a TPR file has been successfully generated. तो एक बार देख लेते हैं कि TPR फाइल जनरेट हुआ या नहीं. देखो यहाँ पर ion.tpr file we have successfully generated. That means we are on the right track. Okay, now once the TPR file is generated, now we would use that TPR file to calculate the number of ions that are required to perform the charge neutralization, right? So इसके लिए again we need to select the newly created TPR file. Then we need to again select the topology file, right? And the thing is, if you remember, we have replaced the solvent molecule with the sodium and chloride atoms as such. Okay, so what we can do is that we that solvent group was there on 15th position, if you remember, right? So we can add this solvent group index to the value of 15 so that it would kind of replace the water molecule or solvent molecule from your system, and simply push this add ions button. Right, now you can confirm that, okay, at
Excuse me.
position.
Sir,
Yes,
where we have to find that solvent group index, right, sir?
yes, over here you can see 15th.
Okay, sir. This is in topology file or this is in GrowMax, sir?
Topology file में रहता है.
Okay, sir.
Okay. So now this 15 indicate that we are, at randomly we would replace whatever number of sodium and chloride ions that are required to solvate the system. Okay, that is what it means, right? So now always do check that you see this GrowMax mind you command, okay, and that would kind of indicate कि the command has run successfully. Okay, ठीक है. तो ये होने के बाद में now you can just inspect कि you have created this box solve ion. ये फाइल नया तैयार हुआ है. You can also check it in VMD. We can kind of see if we really have ions in it. We can create a representation. We would create representation for ions, right? Okay, you can scroll down to where single keyword like ions are there, and you can create representation. And in draw style, you can visualize it in this. Okay. So you can see that sodium and chloride ions are now shown in the CPK representation as such, or van der Waals, whatever it is. Okay. So we are on the right track, my friends. So let us close this really quick. Yes. Okay. Now we have done ion addition. So we have now added ions, we have now added water molecule around your protein box, and now it is time for your energy minimization. तो energy minimization का टैब उसके आगे ही अरेंज किया हुआ है, right? So all you need to do is to browse the MDP file, right? em.mdp file correspond to your energy minimization. I would open it. Then I would browse to the newly created ionized solvated box of your protein ligand system. Then I would use this updated topology file. And first we would create a TPR file that would contain all the necessary information that is required to run this minimization simulation. Right, like what are the periodic boundary condition, bond length, bond angle, whatever parameters that are there. So it is basically a digital file. It is basically a binary file called as the TPR file that contains data that is essential for your GROMACS to recognize the system. So every simulation has to have its own specific TPR file. Like energy minimization का खुद का TPR फाइल जनरेट करना पड़ेगा अपने को, NVT का TPR फाइल जनरेट करना पड़ेगा, NPT का करना पड़ेगा और प्रोडक्शन का करना पड़ेगा. So the first section usually is meant for generating those TPR files. So once everything is in place, all you need to do is to hit this generate TPR file. Okay. And now you can see that em.tpr file has been generated. That means we are now ready to run the simulation. Making sure that TPR file has been successfully generated. After that, you are supposed to push this run energy minimization. And now you can see the minimization simulation is in progress. Okay, so it didn't take much time on this PC. ये नया वाला PC है. We are working on Windows 11 operating system, and we have shifted from the previous PC to this new PC. Okay, so in this way we can kind of compare कि कितना time लग जाता है अपने को ये चीजें करने के लिए when you shift to a high-end configuration PC. Okay, so अभी आपका एनर्जी मिनिमाइजेशन हो चुका है, राइट? तो वंस यू आर डन विथ एनर्जी मिनिमाइजेशन, ओके, अभी आगे क्या करना है? द नेक्स्ट थिंग इन आवर प्रोटोकॉल इज टू परफॉर्म इक्विलिब्रेशन, एंड दिस इक्विलिब्रेशन are to be done in two stages, as I have said earlier: NVT ensemble equilibration and NPT ensemble equilibration. Okay, so before we perform equilibration, यहाँ पर GROMACS में conventionally equilibration are performed in you can say position restraint fashion, wherein you restrain the position of the atoms of your ligand and protein molecule, and you allow the water molecules and ion molecules to adjust itself and perform the equilibration process as such. We don't allow the protein and ligand molecule to move in the equilibration, और उसके लिए अपने को इंडेक्स तैयार करना पड़ेगा to tell GROMACS कि okay, using this index file there is information of all the atoms that are supposed to be kept static or restrained is there in that index file. तो अपने को indexing पहले करना पड़ेगा, right? So the thing is that position restraint we have already obtained for our protein molecule, right? But we are adding a separate ligand. Therefore, we need to index the ligand first, right? तो ये करने के लिए वी हैव इन दिस सॉफ्टवेयर, we have created a separate functionality. Okay, so whenever it comes to perform this indexing business, you can use this separate index architect tab, right? So whenever you need to perform or whenever you need to index something, this particular tool can be used in our toolkit. ओके, तो अपने को क्या इंडेक्स करना है, मैंने बोला वी हैव टू इंडेक्स द लिगैंड मॉलिक्यूल, राइट? तो यहाँ पर अपन कैन गो एंड ब्राउज दिस लिगडेट ग्रुप फाइल, open it, right? And since we are indexing the ligand, let us give it a proper name, index underscore lig नाम दे देते हैं for time being dot ndx. Okay, and once you give this name to your resulting index ligand, all you have to do is to now hit this generate index button. Okay, now it has kind of invoke the make index command in GROMACS. तो अभी आपको once this command is invoked, you are supposed to provide the indexing information, and you have been offered the indexing information right over here. तो सबसे पहले आपको बताना पड़ेगा कि you can give it like over here, zero, that indicates that we are using the entire system. Then there is another indexing for adding the things. उसके लिए आपको स्पेस देकर यहाँ पर एंड देना पड़ेगा. Last time we have simply copied and pasted things, but I am now showing over here. We are to suppose give this exclamatory mark that indicates not. Okay, we are excluding what A that correspond to the atoms, all hydrogen atoms, right? A hydrogen, star means all atoms. Okay, so this is the indexing information that you are supposed to give, that in find in the entire system. Okay, and provide position restraint to all the hydrogen atoms that are there in your system. That is what we are trying to do over here. Okay, तो ये indexing information देने के बाद में all you have to do is to hit this generate index button. Now it would say that it has created another group called as 3 system and IH star, right? So this is what is required. Okay, good. Okay, now once this index file has been generated, अब ये देखो नया तैयार हुआ है ये स्टेप करने के बाद में. Okay, now let us put the position restraint on our system. तो उसके लिए again we would go to this position restraint tab, right? और position restraint tab में जाने के बाद में select this lig.grow file. इसी के ऊपर अपने को सारा position restraint का डेटा डालना है, right? And where is that indexing information available? In this newly created file. We would select it, and then we would select this generate. We would use this generate position restraint button. Okay, now in my previous step I have said that we have created a new group called as group 3, wherein all the ligand indexing system is there. Therefore we need to tell that we need to select this third group which contains all the ligand indexing information, and hit this send index button. And now my friends, you have created a new file called as position restraint underscore lig.itp. So it contains this ITP file contains all the ligand position restraining information. Okay, so what to do now? Now we have with our hand all the indexing information that is required for indexing the ligand atoms. Okay, but still our system don't know where to look for position restraining the ligand, right? तो उसके लिए we again have to go back to the text editor and again open the topology file so that we can update this topology file with the newly created position restraint for your ligand. Okay, तो ये जो चीज है इसके लिए आपको थोड़ा नीचे जाना पड़ेगा. Okay, and you need to find out the section जहां पर position restraint शुरू हो चुका है. So posre.itp is for your protein molecule. And now we would update the ITP file where we have included the information on ligand. ठीक है. Okay, so here you have position restraint for protein molecule and position restraint for your ligand molecule. Make sure you always use this save button and then close this thing. Okay, now our system topology file has been properly updated. Again, we have to now create the final index file wherein which we can use for further equilibration process. Okay, so abhi in this index architect tab we need to open this em.grow. Why em.grow? Because we would start our equilibration from the structure where minimization has finished, and we have performed minimization on this em.grow file. Okay, right? Okay, so let us give a new name to this file जो अपन हमेशा यूज करेंगे अभी, index.ndx. ओके, तो ये अपन ने लास्ट टाइम दिया था तो इसको हटाना पड़ेगा. वी नीड टू गिव न्यू इंडेक्सिंग इंफॉर्मेशन ओवर हियर. तो यहाँ पर वी नीड टू हिट दिस जनरेट इंडेक्स कमांड. ओके, एंड नाउ इट हैज ऑफर्ड अस अ मेनू कि भाई जो फाइनल वाला इंडेक्स है उसमें क्या क्या रहने वाला है, right? So what we have index? We have index protein, which is at the first position. Therefore, we will have to send the index, select the option 1 over here and use the pipe button. And the ligand is there on maybe 13th option I see. तो यहाँ पर अपने को 13th option use करना पड़ेगा, right? One pipe 13 indicates that we are supposed to index two groups, protein and ligand together, right? And then again hit this generate index button and it says that command has executed successfully. Okay. So being said and done, now we are ready to perform the equilibration process. तो इसके लिए आपको NVT का पहला वाला स्टेज होता है तो उसका करस्पॉन्डिंग nvt.mdp फाइल आपको लेना पड़ेगा. अपने को एनर्जी मिनिमाइज्ड स्टेट से इक्विलिब्रेशन चालू करना है, देयरफॉर em.grow फाइल आपको लेना पड़ेगा. इसका रेफरेंस भी वी आर गोइंग टू टेक द सेम फाइल em.grow. वी नीड अ टोपोलॉजी फाइल एंड अपडेटेड टोपोलॉजी फाइल, तो वो सिलेक्ट करते हैं एंड लेट अस गिव the location of a newly created index file, right? And let us generate the TPR. Okay, तो भी देखो यहाँ पर nvt.tpr तैयार हो गया. That means we are ready for NVT simulation, right? So in my previous demonstration, I have kind of showed you कि like how do we use automation, right? But यहाँ पर we would be doing this step manually. Okay, तो अगर all you have to do is to hit this run NVT equilibration, right? And now you can see over here that this GROMAX is saying ki we have selected one GPU for this run. Okay, it has mapped that one GPU and it is 100 picosecond equilibration that would be carried out over 5,000 steps. So my friend, for the sake of completing this tutorial in time, I am using this only 100 picosecond of equilibration. So when you actually perform simulations for publishing your data, you should at least perform 500 picosecond of NVT simulation and 500 picosecond of NPT simulation. So ये ज़्यादातर करते हैं अपन, right? Okay, so approximately when I did this thing yesterday on this new PC, it took me about 3 minutes. Okay, so now for 3 minutes, let me show you what exactly happens in the background. Okay, I can use this Control Alt Delete button and start this task manager. Okay, तो ये आपका Windows 11 में आपका task manager कुछ इस तरीके से दिखता है और when you see performance, now you can see that our process or that our simulation that we are जो लगा दिया है अपन ने, that can be monitored over here in process, right? यहाँ पर GMX run हो रहा है, as you can see over here. And in performance section, you can monitor ki how the resources are being utilized. Okay. Now you can see the CPU is being utilized at its 94% of capacity. And GPU is being utilized at, of course, around 97, 98, or you can say 100% capability. तो यहाँ पर GPU का एक लोग ज़्यादातर कंफ्यूज हो जाते हैं कि सर I have bought a new PC, उसमें I already have a GPU, and by that people usually refer to this integrated Intel GPU जो उनके पास में होता है. बट ये जो इंटीग्रेटेड आपके पीसी के साथ में आने वाला इंटेल का जीपीयू होता है, well that is not actually optimized to be run with MD simulation softwares with GROMAX और NMD. ठीक है, तो ये आपको अलग से जीपीयू कार्ड खरीदना पड़ता है. ओके, एंड यू कैन चेक आउट इन योर पीसी कि आपके पास में जीपीयू कार्ड है या नहीं, राइट? तो just make sure that you have this GPU card. and अभी देखो बोलते बोलते ही अपना इक्विलिब्रेशन सिमुलेशन खत्म हो गया, और जैसे ही ये खत्म हो गया the CPU usage dropped down to 4% and GPU percentage GPU भी नीचे आ गया, right? Okay, so NVT equilibration is done. Well, now if you compare what I have said yesterday कि यही वाला जो इक्विलिब्रेशन का जो प्रोसेस अपन ने किया था, इट टुक मी काइंड ऑफ 15 to 20 minutes to get it done on the PC जहां पर सिर्फ CPU था. तो अभी it took only 181 seconds, right? And 181 seconds correspond to approximately 2.5 to 3 minutes, right? तो देखो कितना उसका कैपेबिलिटी बढ़ जाता है अगर आपके पास में जीपीयू रहा तो, राइट? ओके, सो since we have done with this NPT equilibration, let us begin this. NVT हो गया अपना, अभी NPT equilibration करते हैं, उसको अपने को MDP फाइल लगने वाला है, राइट? So we would begin this NPT simulation, okay, using the data that is there in this npt.mdp file. अपने को ये कहाँ से शुरू करना है? जहां पर NVT खत्म हुआ, therefore we would be selecting this grow file. इसका रेफरेंस फाइल भी अपने को ग्रो फाइल ही, एनवीटी का ग्रो फाइल ही रखना है. Open this thing up. Again, we would be using the same topology file. Open it up. We would be using the same index file, index.index, right? Generate the TPR file. Okay. Make sure that npt.tpr file has been generated. And we are now ready to roll with our NPT equilibration. देखो एक और चीज मुझे आपको बतानी है कि generally when the CPU is not being used in your simulation, तो उसका टेम्परेचर कितना है अभी 61 डिग्री सेंटीग्रेड, समथिंग लाइक दैट, राइट? तो अभी now let us see what happens to this temperature when we execute the simulation. Let us hit this run npt simulation, right? तो again now you can see the temperature धीरे 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 बढ़ते जाएगा ये, राइट? एंड लेट अस सी कि एट पीक पर जब रहता है ये, जब इसका टेम्परेचर कितना जाता है. Now you can see the rise in temperature at it is the GPU is now at 83 degrees centigrade. Well, I have kind of monitored this thing and I have kind of noted कि मेरे पीसी में ये 90 डिग्रीज पर जाकर स्टेबल हो जाता है. एंड एट दिस स्टेज माय फ्रेंड आपका सीपीयू मशीन जो होता है वो काफी गर्म होना शुरू हो जाता है, राइट? सो एट द सेम टाइम एक चीज आपको फिर से बता देता हूं मैं कि जो मैंने आपको बताया था कि डैशबोर्ड पर यू कैन सी नाउ जो पहले ब्लू था अभी ये रेड हो गया है. व्हाई? बिकॉज इट हैज डिटेक्टेड दैट 99% ऑफ सीपीयू हैज बीन यूटिलाइज्ड नाउ, राइट? तो करके यहाँ पर ये वार्निंग देना शुरू कर देता है, ये रेड हो जाता है सेइंग कि क्रिटिकल सिस्टम लोड हैज बीन डिटेक्टेड. सो यू डोंट हैव टू वरी, कुछ होने वाला है नहीं. But it is just for your information that your software is utilizing the system at its fullest potential. Okay. So we were doing this 100 picosecond protein, or you can say equilibration simulation. तो अभी interesting thing is that if you monitor this thing, okay, now it has reached 90 degrees, right? Now imagine that I have a very basic graphics card. Well, in my PC we have like NVIDIA RTX A400 graphics card. ये graphics card आप कह सकते हैं कि NVIDIA entry level का graphics card है, right? तो the data centers that are constantly working all over the globe, लोग इतना environmental मतलब उनको इतना ये क्यों लगता है? Why is that they require it? So now imagine कि एक पीसी इतना गर्म हो रहा है, so there is an entire building that is filled with such GPUs. वो इतना गर्म होता है and it requires, such data center requires a lot of water and cooling system to eventually keep the system in place. तो इसलिए वाटर कंजम्पशन के ऊपर में अभी काफी बहस चल रही है कि भाई व्हाई इज दैट इतना पानी क्यों लगता है इन सारी चीजों के लिए. Well, anyhow, it won't take much time for us to complete this simulation. Okay. तो देखो last time when we completed this thing, we were working on a CPU machine, right? और CPU मशीन पर बहुत टाइम लग जाता था. बट नाउ GPU आते ही देखो फटाफट फटाफट ये सारी चीजें होगी. दूसरी चीज आपने नोट की होगी कि द मेमोरी दैट इज यूज्ड फॉर GPU इज वेरी लो, राइट? इट the process utilizes the maximum computational power. प्रोसेसर ज्यादा से ज्यादा यूज होता है, मेमोरी कम यूज होता है इसका, राइट? तो someone asked me yesterday कि भाई if I want to buy a PC जिसमें मुझे ये MD सिमुलेशन का काम करना है, तो this is the reason that I advise him to have a PC with highest possible processor power. तो this is the reason, क्योंकि यहाँ पर मेमोरी कम यूज होता है, यहाँ पर आपका प्रोसेसर बहुत स्ट्रांग रहना चाहिए in order to get things done in reasonable time. Okay, so enough of it now. Let us do the production run. तो यहाँ पर आप सीधा ब्राउज कर सकते हैं आपका MDP फाइल, right? You can open it. This is where all the MD information is. Then you can browse the grow file, which is npt.grow. You are supposed to put the checkpoint file over here. Okay, अपन ने last time npt का checkpoint किया था. Topology file लेना है आपको यहाँ पर. Just select this topol.top. Index file लेना है. Index.index. Okay, and let us generate the TPR file first. Okay, make sure that md.tpr file has been generated. That means our system is ready for simulation. And just hit this run MD simulation. Okay, it says that we are performing 1000 picosecond MD simulation production run, and on my PC जो अभी अपन यूज कर रहे हैं यहाँ पर जो वर्क स्टेशन यूज कर रहे हैं वो 30 मिनट्स के आसपास लेगा. सो आई सपोज कि अपने पास में 30 मिनट्स है तो इसको अपन चालू रहने देंगे, सो दैट बाय द एंड ऑफ द सेशन यू कैन सी कि भाई सिमुलेशन खत्म होने के बाद में वो कैसा दिखता है. ओके, सो लेट अस मिनिमाइज इट. ओके, so this is how now you can see just with the help of few clicks now you are able to set up and run MD simulation. तो मैंने ये सारी चीजें एक्सप्लेन कर रहा था इसलिए मुझे इतना टाइम लग रहा था. But when you do it by yourself, these are simply few clicks and simply few copy paste thing, and your system would be up and ready in 5 to 10 minutes. राइट, तो अभी ये भी बैरियर क्रॉस हो गया कि भाई आई डोंट हैव टू नाउ रिमेंबर एनी कमांड्स, आई डोंट हैव टू I don't have to keep track of what are the files that are available there and किसके लिए कौन सा यूज करना है. राइट, सो व्हेन यू यूज दिस ब्राउज बटन, जो जिसका रेलेवेंट फाइल है वही आपको वहां पर दिखता है. ऑल यू हैव टू डू इज टू सिलेक्ट इट. So we have coded this software in such a way that user has got really very less chances to get it wrong. Okay, all you have to do is to follow this protocol very strictly. Okay.